The imaginary component of the wave equation, psi, is dark matter energy, and that is a fact. And so at the outset, I want to express heartfelt gratitude. Thank you for orbiting in sonic gravity and deciding to spend any amount of time listening to the sonic gravity theory of everything. But I want to point out that in order to really hear and assess theory of everything, it really becomes necessary to abandon the instinct to reject that which we don't agree with or understand differently right when we hear it. Because in order to assess a theory of everything, you really need to kind of just hear it and then ask yourself whether it predicts things that are measurable. Does it yield predictions and outcomes, and does it make sense of the things that we know we see around us? And so at some point, you might hear the sonic gravity theory of everything discuss something like the inversitility of mass and velocity. Because it's the sonic gravity theory of everything that mass varies inversely with velocity, which is why photons are massless, it's why cosmic rays are almost massless, and it's why particles that are accelerated to almost the speed of light appear massless and small, and then on impact, when the velocity drops to way less than the speed of light, all of a sudden they get fat, they get heavy and big. And then when the environment, when an electron gets picked up by a positive ion somewhere and it starts to spin up, it accelerates, it loses some mass. And I know that the scientific consensus is that the particle decays from being a muon into an electron again, and in the process ejects a bunch of antineutrinos. It's the sonic gravity theory of everything that it's just merely accelerating in an orbital vector and losing mass because observable mass comes off the hologram and turns some of that energy into imaginary off the hologram energy, essentially drops some of its mass into a dark matter state to pay for the velocity that maintains conservation of mass energy on the hologram. Because in the sonic gravity theory of everything, we exist in a holographic universe. Our consciousness runs over the surface of a 2D holographic universe, the surface of a black hole. Now, the holographic universe, in my idea, that's Jacob Bekenstein, Gerard Hoof, Leonard Susskind, Stephen Hawking, is their idea. And the sonic gravity theory of everything was really created by cobbling together all the things that I think we really know in physics and seeing how they fit together and trying to put them together. And so the sonic gravity theory of everything is that our consciousness sits on a 2D holographic surface of a black hole, encoding a universe inside. And the only place that our consciousness gets its information from is what's in contact with the hologram. Just like our brain doesn't actually interact with the environment. Our brain doesn't see anything, our brain doesn't hear anything, doesn't taste or smell anything, and it shouldn't touch anything. The brain just interprets electrical signals from our nerves. And so in the same way, our consciousness could be receiving energy from the hologram. And that energy is what we interpret as the universe around us. Now, it sounds like a lot, and if you just say, oh no, that can't be it, you're not going to give it a chance. And if we reject it at the outset, then no theory of everything will ever pass muster, because nobody already believes a theory of everything. So when I say that it's the sonic gravity theory of everything, that our consciousness exists on the 2D holographic surface of a black hole, with space-time blowing out of the black hole from the future to the past, and it's when space-time blows through the surface of the black hole, using the energy on the surface of the black hole to change the hologram. That's what we notice as the passage of time. An SU1 symmetry is the matter and energy oscillating in a circle around the planar holographic surface of the black hole. And when the matter goes forward in time through the surface of the black hole, it's matter, and when it comes back around and goes back through on the backswing into the past, and then comes back around, that's actually loop quantum gravity. It's matter and antimatter. It's why particles are quantumly entangled. When you separate a particle, it's actually oscillating through the surface of the hologram in two different places. And so anytime you observe it going back in time with a certain spin, a certain direction, a certain velocity, it's going to have an antimatter identity somewhere else on the hologram, wherever it comes back through the other side. It explains everything in quantum entanglement, quantum tunneling, quantum teleportation, whatever you want to call it. And SU1 symmetry is that orbital direction, that orbital path through the hologram in two places. The SU2 symmetry, that's quantum gravity. That's the tension in the string, in the Higgs string, that's leashing all the matter and energy to the surface of Planck time. And so tension in that string, tension in the Higgs field, tension in the Higgs string is quantum gravity. And you can imagine the plane of our hologram straight up and down on the y-axis. And the x-axis is time, into the future and into the past. And the tension in the Higgs string from all that matter oscillating around is going to bend space-time. It's going to bend, essentially bend that axis as it's pulling. So that's how energy oscillating through the surface of our black hole bends space-time. That's gravity. And the stronger the stress, the stronger the stretch and tension in the Higgs string, the greater the gravity is, which is a greater deflection in the surface of space-time, which is exactly what general relativity is. So there's a geometric unity between the wave equation as we understand SU1, SU2 symmetry and the surface of the black hole, which is what Einstein was paying attention to. That is unification. And space-time blowing out of the black hole from the future to the past is actually space-time blasting out of black holes, which explains universal expansion. Because if every black hole is ejecting space-time, those black holes are blowing other black holes further apart. And space-time is moving through matter. So you don't see matter expanding with that space so much, but you see the distance between galaxies and between galaxy clusters getting greater and greater and greater. And you see the rate at which the expansion happens goes faster the further you look out, because there's more black holes between where we are and where we're looking, the further we look out. And so that's universal expansion. It's really easy. Once you have the sonic gravity theory of everything in the Rosetta Stone of the universe. That is a fact. And I know I just threw a lot at you. I haven't shown you the math yet. It's coming. But I just want you to realize that if our consciousness is surfing on the surface of this 2D hologram, recording information in our memories and in our DNA, then that makes us the universe's mechanism for the law of conservation of information. And we're recording information about the universe inside the hologram, our memories and DNA. And when we die, we leave the surface of the black hole as Hawking radiation. And we carry with us our information in fractal ascension, possibly to the black hole that contains our universe, that contains our black hole. And who knows what then? Do we manifest on the surface of that black hole? Does our consciousness re-manifest inside that black hole in that universe? What's that look like? Is that reincarnation? Do we go to the primordial black hole? Is that heaven? Hard to say. Hard to say, but if our consciousness is energy on the surface of the black hole, and Hawking proved that Hawking radiation carries quantum information away from a black hole, and all current, past, and future Hawking radiation is quantumly entangled, and if our energy, our consciousness, our spirit, soul, vibe, if our DNA is that quantum entanglement from our ancestors and our progeny, then who knows? Maybe our consciousness is on the surface of this black hole. And maybe when we die, we carry that information in our memory and our DNA somewhere else. And if we stuck to the surface of this black hole, who's to say we don't stick to the surface of the next one, or the next one, or the next one? So weirdly, it kind of makes room for the scientific plausibility of life after death, heaven and hell. Who knows? And if we're using the energy on the surface of the black hole to run our brains, our consciousness, and space-time is competing for the same energy to change the hologram, maybe that explains why we get tired. Maybe when we constipate the flow of time, when we're conscious, we slow the flow of time with our consciousness, which is why 6 hours in a traffic jam feels a lot different than 6 hours when we're asleep, when we're unconscious, when we're not taking energy off the hologram. And when we wake up, time's passed much faster. Maybe that explains why, if humans have a 53 million neuron per gram brain and hummingbirds have a 650 million neuron per gram brain, maybe the conscious hummingbird isn't fast because it has fast muscles. Maybe it's fast because it chokes the hologram. It constipates the flow of time, so its time moves much slower. Because the heart of a conscious hummingbird beats 20 times a second when it's awake. When it's awake, not when it's flying, when it's awake. And 1 time a second when it's asleep, when it's unconscious. And that is a fact. Anyway, thanks for listening. Give it a chance. I think it'll surprise you. Maybe. Probably. I'm pretty sure.
On September 27th, 2021, I published a Sonic Gravity episode called Critical Thinking Supremacy, Sonic Gravity Black Hole Genesis, and Intellectual Authoritarianism. And that was the first time I went on record and said that a black hole isn't a big ball of dirty mass. A black hole is a wormhole to another universe. And the black hole in the middle is actually empty. It's surrounded by quantum gravity, which is tension in the Higgs string. And that happens when the conservation of angular momentum of a collapsing star forces the star at some radius to spin faster than the speed of light. And Einstein told us that anything that moves faster than the speed of light must go back in time, and that is a fact. So the material in the core of that star, forced to spin faster than the speed of light, goes back in time. It rips out of our instance of Planck time. And since no instance of time in the past can accept it without violating the law of conservation of mass energy, it goes back before the beginning of time and big bangs into its own universe. And so here I derive the equations for the conservation of angular momentum for a point at the edge of a giant star that collapses. The moment of inertia between the original star and the collapsing star has to stay equal. And what that looks like is like an ice skater. When she jumps up in the air with her arms out, she's spinning, but then when she brings her arms in, she spins up really fast. So the collapsing star is doing a light speed axle, and that's given as mass times the tangential velocity times the radius. And the radius changes from something really, really big to something really, really small, and the mass condenses as a function of volume of a sphere. The equation for the volume of a sphere is 4/3 pi r cubed. So the mass density per unit volume of the condensed star is the mass density of the original star times the big radius cubed divided by the little radius cubed. And that is a fact. Plug everything in, and you find out what the radius is. The example star I used to compute the radius is VY Canis Majoris. Its mass is 17 solar masses. Its outer radius is 1500 times the solar radius. Plug all that in, and the radius at which the core of VY Majoris when it supernovas from the center of the star that achieves the speed of light will be 47 kilometers and change. The Schwarzschild radius, incorrect scientific consensus about the radius of a black hole under the misimpression that the black hole is a big ball of dirty mass. I looked it up on the internet, and it's 50. So it's actually pretty close. So the hoop of material that tears out of our instance of time, it's going to be a donut. And the band of material is going to start at the Voorhees radius. Now the sonic gravity theory of everything is premised that our consciousness runs over the surface of a 2D hologram, but it's not bent into the surface of a sphere anymore. The 2D holographic surface of the black hole is bent into a donut, and that is a fact. And that makes perfect sense, because no matter where you walk on the surface of a donut, it's infinite. You can't walk off the surface of a donut. In any direction you go, the universe goes on forever. And that too is a fact. And the interesting thing is when you think about looking into the surface of a black hole, the cosmic microwave background, if you're really looking into the surface of a donut, the end of the universe would actually be closer to you right in front of you, where the tube, the inner tube of the donut is closest to you. And then the sides of the donut would kind of be like empty holes kind of going away from you. And so that means that the cosmic microwave background would have to be warmer in a spot right in front of you, and cooler at the bottom where the bottom of the donut is, and cooler around the sides where you're actually looking down the tube. And guess what? It is. And that too is a fact. Now in the Virgo constellation, M87 is a black hole that we found with the Event Horizon Telescope on April 10th, 2019. And the scientific consensus is that black spot in the middle is a big ball of dirty mass, but it's not. It's a bunch of empty space wreathed by a donut of space that ripped out of our time and is replaced with a ring of quantum gravity arising from tension in the Higgs string, where the superluminal core of that star ripped out of our instance of Planck time, went back to before the beginning of time and big banged into another universe. And that's exactly what Einstein said we need. Empty space encircled by negative energy density. And negative energy density is the exact same thing as gravity, and that is a fact. And that holds open a wormhole. And that too is a fact. And I didn't make that up. If you don't believe it, you can take it up with Einstein. Because Einstein-Cartan theory holds that a black hole is an Einstein-Rosen bridge, a portal to another universe. And that too is a fact. And guess what else? In March 2021, the Event Horizon Telescope took a look at a black hole in the Virgo constellation, M87. On April 10th, 2019, in the Virgo constellation, the Event Horizon Telescope took a peek at M87, which was a black hole. And that was pretty awesome. And I think the scientific consensus is that the black hole is a big ball of dirty mass, and all that orange light is some kind of accretion disk, but it's not. It's a donut of space that ripped out of our time and is holding open a wormhole to the universe beyond. That is a fact. And in May 2022, the Event Horizon Telescope took a peek at Sagittarius A star, which is a supermassive black hole at the center of the Milky Way galaxy. Now, if we're looking at Sagittarius A star, we're going to be looking at it more from the side, right? So if it's a donut, it's going to be like an oval, and that would have to be a fact. And guess what? It is. And that too is a fact. They need some kind of accretion disk, because if you were looking at an accretion disk from the side, it would have to look like Saturn's rings. That is a black donut, and that is a fact. And guess what else? In March 2021, the Event Horizon Telescope clarified part of the M87 photograph, and you can actually see the surface of the black hole, the black donut, much clearer. And look at the curves. That ain't an accretion disk pointing in super sharply. There's no visual distortion. It's the energy writhing over the surface of the donut. And since the inner radius is smaller than the outer radius, you can see it's cramming in. And that's why those lines look like they're getting a little bit more crammed together as they run from the outside diameter of the donut to the inside diameter. And that too is a fact. So in September 2021, the sonic gravity theory of everything claimed that black hole genesis arose from quantum gravity, when the core of that star rotates faster than the speed of light and goes back in time in big bangs. And the hole in the center of a black hole is space. And through that hole is another universe, and that too is a fact. So on December 9th, 2021, I published a sonic gravity episode called Quantum Gravity at the Speed of Thought. And in it I described the Rosetta Stone of the universe, the geometry of the universe, that once I understood, all of the mysteries in theoretical physics just fell into place, and that is a fact. Now I didn't make up the idea that our universe was inside a black hole, and the surface of that black hole is actually a two-dimensional hologram. That wasn't me, that was Gerard Hoof, probably based off Jacob Bekenstein's black hole entropy solution. Stephen Hawking was in on it, and especially Leonard Susskind. There's probably some other guys that I don't know, but you can thank them, because Leonard Susskind figured out that all the machinery and physics and matter and energy in a universe could be encoded on a 2D holographic surface, and that is a fact. And Stephen Hawking talked about Hawking radiation, those black body radiation, heat, and it's the sonic gravity theory of everything, that our consciousness, vibes, soul, spirit, energy, running over the 2D holographic surface of a black hole, encoding a universe inside. And our consciousness receives information from the surface of the hologram the same way our brains receive information from our senses, because our brain doesn't actually experience the physical world around us. All our brain experiences are input signals, bioelectricity, input signals from our nerves and senses, because our brain is really sitting inside a sensory deprivation chamber inside our skulls. It's just interpreting energy that it receives. And the sonic gravity theory of everything is that our consciousness could actually be sitting on the surface of this hologram. And I don't want to blow your mind too bad, but we are the cosmic librarians, the observers in the universe, and we are the mechanism for the law of conservation of quantum information. And we're recording information in our memories and in our DNA. And that's as far as I'm going to go with that one for right now. I don't want to totally freak you out. But later on, we're going to pick up where we left off with that. And then I'm really going to bake your noodle. And that is a fact. Because right now you're orbiting in my sonic gravity and you are viewing the universe through the eyes of a madman. And this is a theory of everything, so we got to be careful not to totally zip off in random stream of consciousness directions. But the main takeaway for this observation that we're making today, right now, in your mind, is our consciousness can only receive information from the changing hologram. So if it's not in contact with the hologram, it's not observable, and it's nothing that we can interact with. It's nothing that our consciousness can interact with, and that is a fact. So if it's off the hologram, it's what we call weakly interacting. It's what we call weakly interacting particles, or WIMPs, or maybe weakly interacting energy is better. And we could just call it we. Anyway, if it's off the hologram, it's wimpy, and that too is a fact. Because one of our limitations as observers is if it's not in contact with the hologram, we can't see it, and that too is a fact. Except that we'll see that the Higgs string, the gravity, is still tugging on the hologram even when matter is orbiting off the hologram. It's still tugging on the hologram, so it's still deflecting space-time. It's still deflecting the two-dimensional holographic surface of the black hole, so it still bends light, and it still has gravity, even though it's off the hologram, and that too is a fact. So yeah, sorry Mond. You can just throw all those draft papers in the garbage, cause that's pretty much it for Mond. And that too is a fact. And I didn't mean to slay Mond. It's just collateral damage. I didn't even intend to sort out the theory of everything. All I wanted to do was figure out how UFOs fly. It's just weird. It just happened. And when it did, I just figured everything else out too. And that is a fact. Probably. Maybe. I'm pretty sure. And so to all those Mond haters out there, you're welcome. And in the math, when it's off the hologram, it's what you call a complex number. It will show up as an imaginary number, which is identified as multiplied by the square root of -1. And that too is a fact. And we'll come back to this when we get into the Quantum Lagrangian, but that's what it means in the math when you see a little italicized lowercase I in whatever equation you're looking at. It's off the hologram if it's multiplied by a I, by a little lowercase italicized I. And that is as a fact. And we'll talk about it later when we cover the equation for quantum gravity and universal expansion. But space-time actually blows out of the black hole. Space-time blowing out of the black hole, which is the reason that the universe is expanding the farther you look out, because there's more black holes between you and wherever you're looking. Space-time blowing out of the black hole is changing the hologram, and that's what we notice as the passage of time. So I want you to think of the universe as a movie reel, one of those old school movie reels. And every frame in the reel is a picture of the exact energy state of the universe at that instant of Planck time. And if we chop all the frames out of the reel and stack them from the beginning of time, from the Big Bang to the end of time, the distance across the edges of those frames of Planck time becomes time-like, from the beginning of the movie to the end of the movie, across the stack, across the slices of cheese. And I made a misstatement during the last sonic gravity theory of everything sort of illustrated tutorial that I did about black hole genesis, because I said that if you were to go, because I said that the spot, the hole in the quantum donut that was a black hole, that if you went through that, you'd go somewhere like to the next, you'd be able to enter that next universe. And I don't think that's right. I misspoke. I wasn't totally critically thinking, because the space inside the radius that we calculated, the luminal velocity radius, the Voorhees radius, wasn't moving faster than the speed of light. So it never left its instant of Planck time. It didn't go back in time. And so when the supernova happened, everything that was inside that little donut hole should have blown out as stardust in the supernova. The same way that the sort of outer layers of the plasma of the star, when it collapses, I think it provides some confining pressure that really holds the core in so that the core can actually spin at superluminal speed. But I think the outer layers of the plasma also form a big part of the stardust and material that blows out when the space-time rips and the quantum donut goes back in time. And it goes back in time just like Einstein said it would, and none of the slices of cheese in the past can accept it, because it would violate the law of conservation of mass energy, and it would be creating energy in that instant of Planck time. So every Planck time rejects it until it goes all the way back before the beginning of time. And then the space inside that quantum donut, that mass that went all the way into the past because it was spinning superluminally, I think the tension in the Higgs string rips open that core, and the weak nuclear force rends all the matter into pure energy. And the space that was inside the core of that star, still quantumly entangled to the edges of space in the parent universe, inflates, results in a Big Bang, and all the energy and space in that universe is sort of field tied, is quantumly entangled to the instant of Planck time way in the future where the black hole ripped out. And it's that tension, it's that gravity that is pulling the space and energy, expanding it in the baby universe, but blowing it, but pulling it back into the parent universe. And that's one of the big mysteries that theoretical physicists don't understand right now, and that's what they're calling dark energy. It's really just the space-time that's uncoiling out of the baby universe, out of black holes, into the parent universe. And that's why I think space-time is uncoiling into the parent universe out of the black hole. And I think the Higgs field is negative energy density. I think it's gravity. And it's that tension in the Higgs string between the baby universe and the parent universe. That quantum gravity, that tension in the Higgs string, is what creates black hole gravity. And the reason that black holes evaporate and slowly get smaller is because as the age of the baby universe approaches the age of the parent universe, where it ripped out of time, the tension in the Higgs string is relaxing. And when the baby universe, because everybody knows that time stops at the surface of a black hole, when the baby universe, the space in the baby universe, when the baby universe's age catches up to the age of the parent universe, I think the space-time is healed. And all the space in the baby universe is uncoiled into the parent universe. And that is probably a fact. Maybe. Probably. I'm pretty sure. But for dark matter, the takeaway is that every one of those slices of cheese, every one of those instants of Planck time is one Planck length thick. And you've probably realized that the sonic gravity theory of everything suggests the Higgs field is the gravity field, and the Higgs boson is the graviton. And that the job of the Higgs field, that the Higgs field exists inside the plane of that slice of cheese, of that instant of Planck time, in the frame of that movie. And the job of the Higgs field is to leash the matter and the energy in that slice of cheese, in the universe, to that instance of Planck time. And quantum gravity is the tension in the Higgs string, tension of the string getting dragged across time via time dilation. But now that we understand that each one of those instances of time, each one of those slices of cheese or frames in the movie, that all the matter and energy is leashed to that instance of time by the Higgs field. And you're going to see, and the geometry of that leash is what's going to give us dark matter. So the 2D holographic surface of the black hole is the state of energy across the entire universe at one instant of Planck time. And if we peel the surface of the black hole off and hang it like a sheet, and if we look at it sideways down the skinny 1 Planck length wide dimension of that sheet, the Higgs field, you can think of the Higgs field as embedded in that sheet. And you can think of the Higgs string as anchored inside that instance of time, inside that slice of cheese, and it's leashing all the matter and energy in the universe to that one instance of Planck time by the Higgs string. And so it's really like a tether. And you can think of all the matter and energy oscillating in a circle leashed to that plane at one point by the Higgs string. And the smallest thing anything can be is 1 Planck length. So I think the Higgs string is 1 Planck length long. And so matter can stray 1 Planck length to the left or right, forward in time or backward in time, without engaging the Higgs string. But when it goes 2, that's when the Higgs string engages and whips it back to the other side. So the matter and energy is oscillating in a circle, in a 4 Planck length diameter circle, whipping around and around in a circle, putting tension on the Higgs string. And the tension on the Higgs string is yanking on the surface of the black hole, on the surface of space-time. And it's that tension that warps light and does all the things that gravity does, because it's quantum gravity. And as you can see, when that matter whips around in that 4 Planck length diameter circle, it only intersects the hologram at 2 places, like at the 12 o'clock position and the 6 o'clock position. It's going into our time from the future and coming out of our time from the past. It's only in 2 different spots, and that's really important, and it will reveal a lot of mysteries in theoretical physics that you will see in just a second, and that is a fact. And so you can see in that little picture, I drew it in and I colored in the circles where the matter is all oscillating off of the hologram, and in the empty circles, like the white circles, they're in contact with the hologram, and that's only the observable part of the matter in the universe. So really only seeing like the tip of the iceberg of the matter in the universe. We can only see it interact with it when it's intersecting the hologram, because that's where our consciousness gets its information from. But you can see how even though like when the matter's all oscillating around, it's still tugging on the Higgs field. It's still tugging on the Higgs string. All that matter oscillating around is still tugging on the Higgs string. It's pulling on the Higgs field on the surface of the black hole. Now it's still there, but we can't interact with it. It's identified in the math as imaginary. And yeah, that is dark matter. That is exactly what dark matter is. That is all dark matter is. It's our matter. We just can't interact with it because it's off of the hologram. And that is a fact. So yeah, if you're working on papers about dark matter and you're trying to say it's like some kind of exotic particle or whatever, you can just throw them in the garbage, because guess what? Our matter is dark matter, or dark matter is our matter, or part of our matter. You know what I mean. So all you Mond people who are dark matter haters, who are still mad about having to throw your papers in the garbage, well, guess what? Everybody else who's looking for dark matter has to throw their papers in the garbage too, and that is a fact. So you're welcome. Now it's even. Everybody has to throw their shit in the trash, and that too is a fact. But now that we know what dark matter is, it's time for the main event. Here's the derivation of the God equation. So we look at all the matter in that diagram. It's all oscillating around a 4 Planck length diameter circle. And what that means is that the circumference of the orbit comes from regular geometry. It's pi times the diameter is the circumference of a circle. And so pi times 4 Planck lengths tells us that the orbit is 12.55 Planck lengths long. But because the hologram is 1 Planck length thick, and the orbit intersects the Planck length thickness of the hologram twice in its orbit, for only 2 Planck lengths of that orbit is the matter in the universe observable. And that leaves 10.55 or 10.6, just rounding up, Planck lengths of unobservable matter. And during that 10.6 Planck lengths per cycle, that matter is dark matter, and that is a fact. It's still got gravity. It's still there tugging on the Higgs field, which is bending space-time, because the Higgs field is inside our slice of cheese. It's inside our 2D holographic surface of our black hole, and it's bending it as it tugs, as that matter swings around and tugs on it. So it's still gravity, just like general relativity says, bending space-time the same way general relativity says that mass bends space-time, because mass is energy, and so is this. But 10.3 Planck lengths of that orbit is dark matter. And so when you put the ratio of 2 2 Planck lengths to 10.3 Planck lengths, and you reduce it down, you get the measured ratio of matter to dark matter in the universe, which is 1 to 5.3 or 5.25, 1 to 5, and that is a fact. And that's actually measured by physicists, so you know it's right. That too is a fact. And so the God equation for the energy of mass, which is just E equals mc squared, only except for it includes all of the dark matter that Einstein didn't know was there. So the God equation for the energy of mass, the Einstein-Voorhees energy of mass, the God equation is 4 pi divided by the g factor for the electron times the observable mass times the speed of light squared. And that's just E equals mc squared, except for you're labeling m as only the observable mass, and then you're factoring it, essentially 4 pi divided by 2, so that it catches all the mass in the orbit. And that is a fact. That is the God equation. And that too is a fact. And so this G factor that I just threw into the God equation, I haven't really talked about it, but I want to explain it because if somebody doesn't know about it, I don't want them to think that it's just word salad and I'm making it up. But the G factor is also a mystery in theoretical physics that we're going to cover, and that's like a completely different mystery that this Rosetta Stone of the universe totally resolves. The God equation in dark matter totally resolves the G factor problem, and also reveals why the Fermi lab discovered that the muon G factor is bigger than the electron G factor. And they're talking about, oh, it's new physics. It's not new physics. It's really easy. But the thing is I'm about ready to talk about it, and that's like a whole separate, different mystery of physics, and I just want to know if they're going to bundle it all, like if it was my birthday on Christmas, and they're just going to give me one Nobel Prize for it, because I told everybody why the muon G factor Fermi lab experiment was what it was, why the G factor was what it was, and what the God equation for the energy of mass is, and what dark matter is, and I already gave away dark energy. And so even though I'm throwing all this in one little tutorial, I really hope that the Nobel Prize Committee kind of looks at it with an open mind and says, you know what, we're not going to give you your Christmas present and your birthday present rolled together, Brad, because you deserve a Christmas present and a birthday present. So I hope they view these as separate Nobel Prizes. Oh, and don't forget Black Hole Genesis, where we all found out that black holes are donuts. Oh yeah, and I think I already gave away dark energy too, which also totally explains universal expansion and the cosmological constant, so, well, you're welcome. Tell on that. Anyway, sorry about that. Let's get back to the G factor. So the G factor is essentially 2. And a G factor was the cheat that arose from the Einstein-de Haas effect, which is from a pretty brilliant experiment where Einstein and de Haas hung a big block of iron and put it in a magnetic field. And when the iron was not in the magnetic field, you know, all the electrons were all just kind of jumbled up and rotating around in random directions and everything was still. But then when you apply the magnetic field, it kind of straightens out all the electron orbiting and essentially sort of pushes off. You know, the inertia is conserved, the angular momentum of those electrons is conserved, and when they all flip over, the thing starts rotating. And that's because of conservation of angular momentum. But the funny thing was that when they calculated the electromagnetic dipole moment, which is essentially the spinning energy of all them electrons zipping around, they did their theoretical calculation, and the measured value was always twice what the theoretical calculation was. And so they just did like they do for the free energy electron in Feynman path integrals and all that kind of stuff, is they just cheat. And they say, well, we're going to multiply it by 2, and then we know we're good. And they call that the G factor. But the thing is, the reason that the G factor is the G factor and the G factor is 2 is because Einstein and de Haas didn't realize that all the matter in the universe was orbiting, tethered by the Higgs string, anchored in the two-dimensional holographic surface of the black hole of our universe, into the space-time of the universe. And when it swings around, like the picture we just described, the Rosetta Stone of the universe, all that matter is orbiting in a 4 Planck length diameter circle, and it's intersecting the hologram at 2 spots, the 12 o'clock and the 6 o'clock, or the pi over 2 and the minus pi over 2 position, however you want to call it. And what that means is that there's 2 impulses along the swing, not just one. And that's why the Einstein-de Haas effect and the G factor had to be 2, because they thought it was just swinging around with one impulse, but no, it's swinging around, hits the hologram twice, and so there's actually 2 impulses per cycle. And that's why the measured electromagnetic dipole moment is twice what the theoretical calculation is. But if you have the Rosetta Stone of the universe and you base it on that, then the theoretical calculation matches the measured electromagnetic dipole moment, and that's a fact. But there's also an anomalous electromagnetic dipole moment, and that's also explained by the Rosetta Stone of the universe, because the sheet of Planck time actually isn't straight up and down, right? It's part of a donut. And so that means no matter where you slice it, it's curved. curved. And so the anomalous electromagnetic dipole moment is actually the extra fractional contact with the hologram because it's bent down a little bit, because it's curved. And so it also explains the anomalous electromagnetic dipole moment, which is the electromagnetic dipole moment for the electron is like 2.00016 or something like that. So it's a teeny little fractional extra amount of moment that arises from the extra contact from the curvature of the black hole, or the donut, so to speak. And that is probably a fact. Maybe, probably. I'm pretty sure. And then if you remember the muon G2 experiment, everybody thought it was such a big deal. And I'm actually going to kind of rain on that parade a little bit too, because there's actually no difference between the muon and the electron. It's just velocity, because things change mass depending on the velocity. But that is the Quantum Lagrangian. And I'm keeping that in a separate one because I don't want that to be the same Nobel Prize as this one. And actually, really, I got to break it down and put it in a different one because, you know, these get kind of dense and everybody kind of gets tired of thinking about it. So anyway, it's coming. In the Sonic Gravity podcast, I am talking about the Quantum Lagrangian, and that's going to be probably one of the next tutorial videos I do. But you could probably figure out everything about the Lagrangian from the 2 tutorial videos that I've got now, this one plus the black hole genesis video. Anyway, bottom line is that the reason that the Fermilab discovered that the muon, which is just incorrectly thought of as a higher energy sort of electron particle, it's just a slower electron, just saying. And they think it decays, but it doesn't really decay, it just accelerates as some positive ion picks it up and it starts to orbit at the speed of light almost. Anyway, bottom line is that when the muon, or the electron, is released when the atom that it's orbiting explodes, they calculated, or they measured, the electromagnetic dipole moment of the muon, and they found that it was a little bit bigger. The G factor for the muon was a little bit bigger than the G factor of the electron. And that makes perfect sense when you look at the Rosetta Stone of the universe, when you take a look and you see that the electron is orbiting around a 4 pi diameter circle, intersecting the hologram at 2 places. Well, imagine if that electron is 200 times as massive, right? If the electron has 200 times more observable matter, right, then it's going to swing out a little bit further, right? We're going to be able to observe it. We're going to be able to measure it, and it's going to stretch out and rotate out a little bit further than the electron. And so that's going to give it a bigger moment arm. So it's going to give it a little bit bigger torque. It's going to give it a little bit bigger moment. And it's obvious, right? Yeah, it's not new physics. It's not a new particle. It's actually just totally obvious, right? I mean, if it's heavier, it's going to swing out further. It's going to cause a bigger dimple in the surface of the hologram where the tether is anchored, where the Higgs string is anchoring it to our instance of Planck time. And so that's why the muon G factor is a little bit larger than the electron G factor. That's all it is. It's really nothing, right? So, I mean, it's obvious once you have the Rosetta Stone of the universe to look at. And that is a fact. So there you go. That's the sonic gravity Rosetta Stone of the universe. Quantum gravity is tension in the Higgs string. Dark matter is matter and energy off the hologram, but still tethered to the surface of our 2D holographic black hole. Dark matter is still the same matter and energy that comprises the universe. It's just off of the 2D holographic surface of the black hole. It's identified in our calculations as imaginary until it intersects the black hole and we can interact with it and it becomes observable. The God equation, the Einstein-Voorhees energy and mass equation, is 4 pi divided by the G factor for the electron times the observable mass times the speed of light squared. And that explains the Einstein-de Haas effect. It reconciles the Fermilab's muon G2 factor experiment results and explains the anomalous electromagnetic dipole moment. And just as collateral damage, we also covered universal expansion. We already covered dark energy. We got all the people who were working on Mond papers to throw them in the garbage, and then we made them feel better because we made everybody who's also working on dark matter throw theirs in the garbage too, and that is a fact. So thanks for listening. Stay tuned for the Quantum Lagrangian and the solutions to all the rest of the mysteries in theoretical physics. We're not just going to talk about all the boring mysteries in theoretical physics that people have thought of that can't figure out. I'm going to give you the solution to the Yang-Mills mass gap. I'll tell you how UFOs fly, anti-gravity, time travel, zero-point energy propulsion. But the cool stuff is stuff you've never thought of. Why we get tired. Why can the bumblebee beat its wings at 600 times a second? Why is the hummingbird so fast? I'll give you a clue. It's not because it has fast muscles. It's because its consciousness slows the flow of its time, and that is a fact. Why your soul is immortal. What happens when you die. It's coming. It's coming as you orbit in sonic gravity and see the universe through the eyes of a madman. So on December 9th, 2021, I published a sonic gravity episode called Quantum Gravity at the Speed of Thought. And in it, I described the Rosetta Stone of the universe, the geometry of the universe, that once I understood, all of the mysteries in theoretical physics just fell into place, and that is a fact. And I didn't make up the idea that our universe was inside a black hole, and the surface of that black hole is actually a two-dimensional hologram. That wasn't me. That was Gerard Hoof, probably based off Jacob Bekenstein's black hole entropy solution. Stephen Hawking was in on it, and especially Leonard Susskind. There's probably some other guys that I don't know, but you can thank them, because Leonard Susskind figured out that all the machinery and physics and matter and energy in a universe could be encoded on a 2D holographic surface, and that is a fact. Then Stephen Hawking talked about Hawking radiation. There was black body radiation, heat, and it's the sonic gravity theory of everything, that our consciousness, vibes, soul, spirit, energy, running over the 2D holographic surface of a black hole, encoding a universe inside. And our consciousness receives information from the surface of the hologram the same way our brains receive information from our senses, because our brain doesn't actually experience the physical world around us. All our brain experiences are input signals, bioelectricity, input signals from our nerves and senses, because our brain is really sitting inside a sensory deprivation chamber inside our skulls. It's just interpreting energy that it receives. And the sonic gravity theory of everything is that our consciousness could actually be sitting on the surface of this hologram. And I don't want to blow your mind too bad, but we are the cosmic librarians, the observers in the universe, and we are the mechanism for the law of conservation of quantum information. And we're recording information in our memories and in our DNA. And that's as far as I'm going to go with that one for right now. I don't want to totally freak you out. But later on, we're going to pick up where we left off with that. And then I'm really going to bake your noodle. And that is a fact. Because right now you're orbiting in my sonic gravity and you are viewing the universe through the eyes of a madman. And this is a theory of everything, so we got to be careful not to totally zip off in random stream of consciousness directions. But the main takeaway for this observation that we're making today, right now, in your mind, is our consciousness can only receive information from the changing hologram. So if it's not in contact with the hologram, it's not observable, and it's nothing that we can interact with. It's nothing that our consciousness can interact with, and that is a fact. So if it's off the hologram, it's what we call weakly interacting. It's what we call weakly interacting particles, or WIMPs, or maybe weakly interacting energy is better. And we could just call it wee. Anyway, if it's off the hologram, it's wimpy, and that too is a fact. Because one of our limitations as observers is if it's not in contact with the hologram, we can't see it, and that too is fact. Except that we'll see that the Higgs string, the gravity, is still tugging on a hologram even when matter is orbiting off the hologram. It's still tugging on the hologram, so it's still deflecting space-time. It's still deflecting the two-dimensional holographic surface of the black hole, so it still bends late, and it still has gravity, even though it's off the hologram, and that too is a fact. And in the math, when it's off the hologram, it's what you call a complex number. It will show up as an imaginary number, which is identified as multiplied by the square root of -1, and that too is a fact. But that's what it means in the math when you see a little italicized lowercase I in whatever equation you're looking at. It's off the hologram if it's multiplied by a I, by a little lowercase italicized I, and that is a fact. So I want you to think of the universe as a movie reel, one of those old school movie reels, and every frame in the reel is a picture of the exact energy state of the universe at that instant of Planck time. And if we chop all the frames out of the reel and stack them from the beginning of time, from the Big Bang to the end of time, the distance across the edges of those frames of Planck time becomes time-like, from the beginning of the movie to the end of the movie, across the stack, across the slices of cheese. But for dark matter, the takeaway is that every one of those slices of cheese, every one of those instants of Planck time is one Planck length thick. And you've probably realized that the sonic gravity theory of everything suggests the Higgs field is the gravity field, and the Higgs boson is the graviton. And that the job of the Higgs field, that the Higgs field exists inside the plane of that slice of cheese, of that instant of Planck time, in the frame of that movie. And the job of the Higgs field is to leash the matter and the energy in that slice of cheese, in the universe, to that instance of Planck time. And quantum gravity is the tension in the Higgs string, tension of the string getting dragged across time via time dilation. But now that we understand that each one of those instances of time, each one of those slices of cheese or frames in the movie, that all the matter and energy is leashed to that instance of time by the Higgs field. And you're going to see, and the geometry of that leash is what's going to give us dark matter. And if you didn't see that, check out Dark Matter and the God Equation tutorial, and you'll see what I mean. But quantum gravity uses the Rosetta Stone of the universe the same way. And because the function of the Higgs field is to leash the matter and energy in the universe to its specific instance of Planck time, when we experience time dilation by moving through a gravity field or accelerating through space, that gravity, that gradient in velocity and gravity, gravity, we'll see that that actually causes gravity. That causes quantum gravity, and that's the thing that we feel when we accelerate in a car or take off in a rocket. And it's precisely why we don't feel gravity when we jump out of a plane, even though we're moving faster through space, falling, than we do in our vehicle. We feel G's in our vehicle when we hit the gas, but we don't feel G's when we jump out of a plane, even though we're falling down faster than we're going in our car. And I keep saying tension in the Higgs string. Tension in the Higgs string is quantum gravity. And it is. And what that means is when our time is dilated, when our time slows down or speeds up, it's the Higgs field that's trying to keep us leashed to our instance of time. As our time is dilated, that stretches the Higgs string, because the Higgs string is connected to us and it's trying to hold us in one spot. And so when our velocity changes our relative time, or a gravity field changes our relative time, we're going to feel that tug. We're going to feel that stretch in the Higgs string. And when we do the Quantum Lagrangian, we'll find out that the reason that tug is happening is because the W boson is forcing a teeny weeny piece of our matter into a dark matter state. And so, that's what the quantum Lagrangian is, and I will get to that in a different video. And nobody knows what that is right now, because that's the sonic gravity theory of everything. So that is not generally accepted physics, but in order to judge the sonic gravity theory of everything, theory of quantum gravity and the quantum Lagrangian, you have to hear it first. There's no one in physics that will go, oh yeah, I've heard that before. And the only way to assess the validity of a theory of everything is to look at what it predicts, look at the logic and the mechanics behind it, and then check and see if that makes sense with the other things that we know in physics. And guess what? It does. And that is a fact. And I'll try to do a good job of explaining what's woo or new and what's generally accepted, scientific consensus in physics. Because a lot of this is absolutely what is known in physics. So the 2D holographic surface of the black hole is the state of energy across the entire universe at one instant of Planck time. And if we peel the surface of the black hole off and hang it like a sheet, and if we look at it sideways down the skinny 1 Planck length wide dimension of that sheet, the Higgs field, you can think of the Higgs field as embedded in that sheet. And you can think of the Higgs string as anchored inside that instance of time, inside that slice of cheese, and it's leashing all the matter and energy in the universe to that one instance of Planck time by the Higgs string. And so it's really like a tether. And the sonic gravity theory of everything accepts Einstein's two main axioms of relativity. One, the invariance of the speed of light. The speed of light is the same for all observers. And two, the equivalence of gravitational and inertial mass, which is the weight induced by acceleration is fundamentally the same as that induced by gravity. And it's called the equivalence principle. And that's actually a big clue, because the weight induced by acceleration is quantum gravity. But it's not described like it is in Newtonian mechanics, where force equals mass times acceleration. Even though that's true, in quantum gravity, it's all about time dilation and the stretch in the Higgs field as we accelerate, as our time dilates. But it's actually kind of the same thing, which makes a lot of sense, because it's not just space, it's space-time. And the Newtonian law of gravitation is all about mass in space. But mass is just energy, and space is space-time. So quantum energy is time gravity, the same way that Newtonian mass gravity is space gravity, because it's space-time and mass is energy, so it's all the same. And that is a fact. Now, that's not necessarily a scientific consensus, but it is the sonic gravity theory of everything, and I think it's pretty obvious when you think about it. Or maybe it's a little arrogant to say it's obvious. I think it's obvious if you are looking at the universe through the prism of the Rosetta Stone, the sonic gravity Rosetta Stone of the universe. But I think it's undeniable that what I'm saying about mass is energy and space is space-time, like that is consensus. And it's pretty elegant. And you'll see there's kind of a beautiful symmetry with what we already know about gravity. And if you don't see it yet, you will see in just a minute. Okay, so first I want to explain a little bit about what time dilation is. And so we're going to look at kinetic time dilation. And this is completely accepted special relativity in physics. This is not controversial at all. So what I'm drawing up for you are two what we call photon clocks. And since we accept the invariance of the speed of light, we know that the speed of light travels constantly at about 300,000 kilometers per second, and nothing can change the speed of that photon, which is light. And there's a little photon inside a cylinder, and there's a clock on the top of the cylinder. And that photon goes down, it bounces off the bottom of the cylinder, and it goes back to the top. It goes down along path A and comes back to the top along path B. And when it hits the top of the clock, that's when the little hand moves a tick. And since the speed of light never changes, the clock maintains perfect time, and that is a fact. So now in clock one's going to sit still. Photon's going to go up and down and run the clock that way. Now in clock 2, it's the exact same clock as clock 1. It's got a photon in the middle too, and the photon in clock 2 is going just as fast and identical speed as the photon in clock 1. But now we're going to slide clock 2 sideways. And what happens is the photon that's in clock 2, it's still going up and down inside that cylinder, but as you slide that cylinder over, the photon doesn't really go straight up and down anymore because it has to stay with the clock, so it kind of has to go at a diagonal. And you can see that because the speed of that photon is exactly the same in clock number 1 as clock number 2, because clock number 2 has to go at a diagonal, the same distance A that both photons cover in the same period of time, since clock 2 had to go at a diagonal, A doesn't get it all the way to the bottom of the cylinder. And so it has to use a little bit of B to get to the bottom of the cylinder for it to, and then when it bounces back up, B isn't really long enough. B isn't a long enough distance that it covers over the same time as clock number 1. When clock number 1 hits the roof of the cylinder, B has not hit the roof of the cylinder yet, and that is a fact. And that's why the faster you move through space, the slower you move through time, because the time in clock 2 is going to tick slower than the time in clock 1, and that too is a fact. That is kinetic time dilation. And the opposite is true. The slower you move through space, the faster you move through time. And that is a fact. And when our time dilates, when we speed up and our time dilates, that's called passing through the curvature of time. Your time is changing from constant and it's curving to a slower time or a faster time or what have you. And it's actually passing through the curvature of time, the same way passing through the curvature of space that's caused by some kind of mass energy denting the space-time. Passing through curved space causes you to experience gravity, but passing through that curvature of time also causes you to experience quantum gravity, and that is a fact. Because it's not space, it's space-time. And everybody knows that the energy of mass curves space and causes gravity, and that is a fact. So, there's no reason to think that kinetic energy velocity won't curve time the same way that mass energy curves space. Because velocity and mass is just energy, and space and time is just space-time, and that is a fact. And then there's gravitational time dilation. We talked about Einstein's bedrock principles of relativity, that inertial and gravitational force is equivalent. So in the same way that kinetic energy, velocity, causes time dilation, there's gravitational time dilation. And the deeper in a gravity well we are, the slower we move through time. And the further out of the gravity well we are, the faster we move through time. And that too is a fact. And so now, up until this point, the sonic gravity theory of everything and everything that I've talked about, none of this is controversial to this point. This is all well-established, scientific consensus has accepted it. And if you were to post this on Facebook, you wouldn't get banned for spreading misinformation. Probably, maybe, I'm pretty sure. I don't know, maybe you would. Hard to say. And that too is a fact. So we're about ready to get into time dilation and how time dilation causes quantum gravity by pulling energy, like mass energy, across time, through the curvature of time, through different slices of cheese, so to speak. But first we need to talk about how energy in systems is modeled. And so I want you to think of a cliff, and on that cliff is a rock. Now when the rock is at the top of the cliff, it's a certain height, and there's two two kinds of energies in a system. There's potential energy, and then there's kinetic energy. And really, potential energy is height/gravity energy, and kinetic energy is velocity energy. And so when the rock is sitting on top of the cliff at the maximum height, all of the energy in the system is potential energy. And that's given as the mass times gravity acceleration times the height. And then that thing rolls off and falls down. As it goes down, it trades its potential energy, which is its height, for kinetic energy, which is speed. So as it falls, it gets closer and closer to the ground. And as it gets closer and closer to the ground, it gets faster and faster. And so at the very end of the trip, from the top to the bottom of the cliff, right before it hits the ground, it has zero potential energy and it's all kinetic energy. So in that moment, the mass times the gravitational acceleration times the height equals 1/2 mass times the velocity squared. And this energy relationship, because the energy is fixed, there's only a certain amount of energy in the system. And at the beginning, it's all potential, and then at the end, it's all kinetic in this particular example. Now, the Lagrangian, instead of using forces on the rock and describing it with all these Newtonian mechanics, the Lagrangian uses the energies in the system that we just talked about, and it summarizes the sort of dynamics in the system. But any function that generates the correct equations of motion in agreement with the laws of physics can be taken as a Lagrangian. And the Lagrangian is given as the kinetic energy minus the potential energy. And if you sum that over time, over the time that you're measuring the system, the sum of the Lagrangian is what we call the action. And I'm not going to get into the action right now, but what I want you to remember is that when you look at the Lagrangian, which describes the dynamics in the system, the Lagrangian is the kinetic energy minus the potential energy. So it's like the velocity minus the gravity, so to speak. That is a fact. Now, up to this point, there is nothing controversial in pretty much anything I've said so far. But here's where the sonic gravity of everything sees quantum gravity, where the scientific community hasn't seen it so far. And I've said this all the time, a whole bunch. Every time I start talking about the sonic gravity theory of everything, quantum gravity is tension in the Higgs string. And that tension arises because the Higgs field leashes all the matter and energy in the universe to our instance of Planck time, to our slice of cheese. And we've talked about how velocity and gravity creates a curvature of time, which is the same as pulling matter and energy, dilating their time, pulling that matter and energy into a different slice of cheese backwards or forwards in time. And it's that tension in the Higgs field that's dragging that matter or energy through the curvature of time to a different slice of cheese, so to speak. And so let's take a look at the example of a rocket. Now, a rocket takes off. You're inside this rocket. It takes off. It's accelerating. It's getting faster as it launches and flies through the air. Now, that acceleration slows down your time, because when you move faster through space, you move slower through time. But it's also leaving the Earth's gravity field. And as you pull out of a gravity field, your time speeds up. So gravity is speeding up and velocity is slowing you down. And since we know the Lagrangian is the potential energy, which is where you start, remember our example of the pebble on the cliff, the potential is where you kind of start. So the rocket is moving your potential energy, speeding up your potential energy because you're coming out of that gravity well, which pushes your time forward a couple slices of cheese. But then you're accelerating, and your acceleration is pulling you back into a slice of cheese in the past. And so the tension between the potential energy pulling you forward and the kinetic energy dragging you back at the same time kind of pulls you tight from both ends. And if you do the Lagrangian, if you do the kinetic energy minus the potential energy, you get a negative kinetic energy minus a positive potential energy, and it comes out to really negative time dilation, because it would be like -1 minus a +1, which is -2, which would be a lot of tension, a lot of negative energy density, a lot of tension in that Higgs string. And for another example, you could take a car. You jump in your sports car, you hit the gas. Now you're accelerating, which is slowing your time, except for you're staying at the same level of the Earth, right? Because the road, you're kind of at the same level of gravity in the gravity field, because you're on the surface of the Earth. And so your time is slowing down from the acceleration, but then the gravity is trying to keep your time right where it is. So the Lagrangian is the kinetic minus the potential, The kinetic is slowing your time down, so that's like a -1. And then you subtract the potential energy, but you're not going anywhere. It's not changing, so it's like a -0. So the Lagrangian would be a -1, which is some tension. It's half the tension, say, in the rocket, where you've got the potential energy cranking you forward and the kinetic energy dragging you back at the same time. This is just your kinetic energy trying to drag you back. But you still feel that tension in the Higgs field. You still feel that negative energy density, that pressure as you accelerate. Now, on the other hand, take skydiving. Skydiving, you jump out of a plane, and it's kind of nice. Just don't open your mouth. And when you take the kinetic energy, now you're accelerating because you just jumped out of a plane. So you're accelerating through space really fast, which slows your time down. But remember, you start off where the potential energy is, just like you start rolling when you knock that pebble off the hill. It sort of starts at all potential energy. And you see, because you're falling deeper and deeper into the gravity well, the place where the potential energy starts is falling back through the slices of cheese at the same pace that the kinetic energy is pulling your time. So everything matches, and you never pass through the curvature of time, because the potential energy, which is the place where you sort of start from, is dragging back, and it's following with the time dilation from the kinetic energy. And what that looks like in the Lagrangian is kinetic energy minus potential energy. So you have kinetic energy, which is -1 because you're going faster, and then you have a minus, but then the potential energy is also -1 because you're falling deeper into a gravity well. So you have -1 minus a -1, which is the same as a +1. So you have 0. And that's why there's 0 tension in the Higgs field when you skydive. There's 0 time dilation when you jump out of a plane, even though you're moving way faster through space, falling, than you do in your car. But you feel gravity in your car because of the Lagrangian. You feel no gravity when you skydive. And that's why Einstein famously said, if you want to escape the force of gravity, jump off of a building. And that sounds crazy, but that's what he meant, and that is a fact. And this is not particularly controversial. The only thing that I think nobody's really thinking about, or nobody has envisioned in terms of quantum gravity, is the Rosetta Stone of the universe, which is the movie reel, the slices of cheese, the frames in the film. That's the only thing, I think, that image is the only thing that the scientific community hasn't put together yet. And it's exactly how we derive the equation for quantum gravity, and that is a fact. But this is how time dilation causes gravity, moving through the curvature of time. And quantum gravity is that tension in the Higgs string as it stretches across time dilation, as it tries to do its job to leash the matter and energy to our instance of Planck time. And when the time is dilated, it will stretch the Higgs string. And the stretch in the Higgs string is what you feel as G's, as acceleration. And that is probably a fact. Maybe, probably. I'm pretty sure. No, I'm totally sure. That too is a fact. So now it's time for the main event. Now we're going to derive the equation for quantum gravity. And since we know that quantum gravity arises from tension in the Higgs string across time dilation, we're going to model the tension in the Higgs string the same way in statics and dynamics that we model the tension in a spring. Now, a spring has a stiffness that we call K, and that stiffness is the force that's required to stretch the spring a unit of distance. And so K times the distance, D, is the force in the spring, and that is the force of quantum gravity. It's the tension in the spring, which would be K, the stiffness, times the time dilation, D. So quantum gravity is the tension in the Higgs string, and the more time dilation, the more quantum gravity force. Now, in Newtonian gravity, the force of gravity between two masses, the force equals the gravitational constant times the first mass times the second mass divided by the distance between those masses squared. Now, for quantum gravity, which is time, just intuitively from Newtonian gravity, knowing that space-time is both space, the same way it would be Newtonian gravity, and quantum gravity or time gravity, I'm going to start off in the derivation of the equation, dividing the distance of the stretch times the stiffness of the spring. I'm going to divide it by t squared the same way Newtonian gravity is divided by r squared, because in Newtonian gravity, the further apart you are, the less the gravity is. And in quantum gravity, it makes perfect sense to me, and there's kind of an elegant beauty to it. It should be divided by t squared. And that makes perfect sense, because if you say you have some time dilation, but it takes you longer, more time to achieve that time dilation, then you're going to feel a lot less gravity, right? And that's like the difference between going 0 to 60 in 3 seconds or 0 to 60 in 60 seconds. The shorter that t is, the time that it takes to accomplish that time dilation, the shorter that is, the more gravity you're going to feel. But if you're going 0 to 60 in 60 seconds, that's divided by 60 squared. And so that's going to really cut down on the amount of g-force that you're going to feel. So now let's derive the equation for quantum gravity. We got energy, which is a joule, and the units of a joule is a kilogram times a meter squared divided by second squared. And then force, a newton, is a kilogram times a meter divided by a second square. And so the force, which we know has to be in units of kilogram times a meter divided by second squared, we're going to take the energy of mass, which is what we're going to accelerate or time dilate, times the stretch in the Higgs string, which is a unit of length, which will go with meter. And then the stiffness of the Higgs is a force, which is a kilogram meter per second squared. And then we're going to divide it by t squared, because like we said before. Now, so the energy of mass is E equals mc squared. It's actually 4 pi divided by the g factor times the observable mass times the speed of light squared. But just for simplicity's sake, we're just going to say mc squared, which is kilograms times c squared, times m for meters for the unit of length, the stretch in the Higgs string, and then times the stiffness of the Higgs, which is a kilogram meter divided by second squared. And then we're going to divide it by s squared, which is the dividing it by t squared that we talked about. So then when we kind of do all the math and cancel the units, we're still looking for our force. It's got to be in kilogram meters divided by second squared. But now we have kilograms squared, c squared, m squared divided by s to the fourth. Okay? So we want kilograms, we got kilogram squared. We want meters, we got meter squared, and we want time squared in the bottom, but we got time to the fourth in the bottom. And then we have this pesky c squared in there that we need to get rid of. And so now what we know the equation has to be to get all the units to come out right is we have to square root the whole thing. Because if we square root kilogram squared, we get kilograms, which is what we want. If we square root meters squared, we get m, which is what we want. And if we square root s to the fourth, seconds to the fourth, if we square root that, we get s seconds to the second squared in the denominator, which is what we want. And then of course we got to get rid of that pesky c squared, so we gotta divide our equation by c squared from the beginning so that we get rid of that c squared. So that way, if our equation is the energy of mass times the distance in time dilation times the Higgs string stiffness divided by t squared divided by c squared and then square root, that derivation will give us the exact force units that we need. And that solution will give us a force of quantum gravity. And that is a fact. Now, the only thing that's impractical sort of is knowing what the time dilation distance is across these slices of cheese, because how do you do that? How do you sort out what that distance is? Because it's a distance, it's not really a time. Might be a time, but it's just hard to say. So what we do is we take a look at all of, and this is exactly what they did for Newtonian gravity too. Anyhow, and it makes perfect sense. And so what you need to do is you need to look at, you have constants in that equation, which is c, which is the speed of light, and the Higgs stiffness. We don't know exactly what it is, but we're going to assume that it's constant and elastic so that it doesn't change over time. And we don't think it should, because there's no changing or elasticity over time in regular Newtonian gravitational mass gravity. So I think it's a pretty reasonable assumption. And the time dilation is determinable based on the height and the velocity. That can be calculated. And the energy of mass, whatever we're accelerating, is measured value. And t squared is proper time. So that's just the time over which the acceleration happened. So we could actually actually boil all of those constants into a gravitational constant the same way they do in Newtonian gravity. And so then it would be the quantum gravitational constant times the time dilation in seconds, which we can compute, times the energy of mass, which we can compute, divided by t squared. So it actually looks almost exactly like Newtonian gravity, which there's kind of a symmetry there. There's sort of a beautiful elegance there. Now, does that mean it's right? I don't know, but it's hopeful. Not because, and it's not elegant and symmetric because we looked for something elegant and symmetric. We modeled quantum gravity as tension in a spring across time dilation, which is totally rational. I mean, it just makes all the sense in the world. And it reduced to this. Right? We had no intent to make it pretty. We just kind of used our brains. We modeled it the way we thought made sense. And it just reduces to this gorgeous equation that looks almost exactly like mass gravity, which it should, because mass is energy the same way velocity in time dilation is energy. And it's not divided by r squared, it's divided by t squared. And all the units come out, so have a nice day. So, but the way we would determine what that gravitational constant is we would just accelerate something. And we would record the force, we'd calculate the time dilation, and then we would solve for g. Because the force can be measured from an accelerometer. And then we'd record the time, we could compute the time dilation, and we know how big the mass was, so we could do the energy, we could figure out the energy of the mass, and then that force that we measured would have to be all of those measurements that we did times g. And so essentially, we could compute a g just based on that acceleration experiment, and then do a second acceleration experiment of non-identical measurements, and the g that we computed for the first one would have to solve the second one, the second experiment, for it to be right. And that would be a fact if it was right, which I'm pretty sure it is. So the force of quantum gravity squared equals the energy of mass times the quantum time dilation distance times the Higgs stiffness divided by the time squared over which the time dilation occurred divided by the speed of light squared. And we can boil all the constants down and bake in all the conversion factors with an experimentally determinable quantum gravitational constant with two experiments. And then the equation for the force of quantum gravity becomes the quantum gravitational constant times the kinetic seconds of time dilation minus the gravitational seconds of time dilation, just like the Lagrangian, times the energy of mass divided by t squared divided by c squared divided by t squared times c squared. And so the force of quantum gravity is the square root of the quantum gravitational constant times the Lagrangian of the time dilation times the energy of mass divided by t squared times c squared. And that is probably a fact. Maybe. Probably.
There's no reason to think that the ocean ends just beyond your horizon, and likewise, there's no reason to think that the aftermath of our Big Bang ends just at the boundary of what we can see. Indeed, there are quite strong arguments that it probably goes on about 100 times further. And it may even go on so much further that all combinatorials are replicated, and there's another set of people like us sitting in a room like this. We are still groping for ideas.
But you think first theory will reach into that place, and then experiment will perhaps one day catch up?
Well, I
Maybe
think
simulation.
In a sense it's a combination. I think what we hope for is that there'll be a theory which applies to the early universe, but which also has consequences which we can test in our present-day universe, like discovering why neutrinos exist or things like that. But I think the hope would be that we will have a theory which applies under the very, very extreme early stages of the universe, but which gains credibility and gains confidence, because it also manages to account for otherwise unexplained features of the low-energy world and what people call a standard model of particle physics, where there are lots of undetermined numbers. So it may help with that.
So this is my first tutorial on the Quantum Lagrangian. And in this tutorial, we're going to complete Einstein's equations for the energy of motion, and we're going to simplify the standard model. And we're going to do that using the sonic gravity, Rosetta Stone of the universe, that our consciousness is surfing over the 2D holographic surface of the black hole that is our universe. Now, it's a 2D holographic surface, and our consciousness can only receive information from the hologram. And that means that only the matter and energy in contact with the hologram is what we can measure and interact with. But we'll see that even the energy off the hologram, the matter oscillating, tethered by the Higgs string to the fabric of space-time, still has gravity, and the effects of gravity are still there even though we can't interact with the matter and energy itself. In order to show that the sonic gravity theory of everything is actually the theory of everything, it has to coexist with the things that we know are true in physics. And not just coexist, it has to establish, it has to reflect it, and it has to accurately model the geometry of the universe, that the established equations in physics that we know have been tested and experimentally verified are mutually supportive, and that is fact. It can't be the theory of everything if it isn't the theory of everything. If it isn't right and the puzzle pieces don't fit, it can't be the theory of everything. But guess what? It does, and that too is a fact. And so far in our sonic gravity tutorials, we established the sonic gravity theory of everything and black hole genesis, which you'll really want to watch first if you haven't seen that. We talked about dark matter and the God equation, and then we derived the law of quantum gravity and the equation for quantum gravity. And so now we're going to talk about the quantum Lagrangian. And to tee that up, we got to talk about Newtonian mechanics and what the Lagrangian is, and how the sum of the Lagrangian over time is the action. And then we're going to look at quantum mechanics. We're going to look at the Schrodinger equation, and we're going to see if the Schrodinger equation reflects the sonic gravity Rosetta Stone in the universe. And guess what? It does. Then we're going to talk about the Dirac equation. The Dirac equation really sort of combined the Schrodinger equation and Einstein's special relativity, Einstein's equations of motion. And guess what? It does. And we're going to see the funny thing is that Dirac couldn't get the equation to work unless he modeled it using 4 electrons, 2 opposite electron pairs. And we're going to see how that is exactly modeled by the sonic gravity theory of everything, that our consciousness exists on the surface of a 2D hologram. And if you turn it sideways and you look at all the matter and energy tethered to the fabric of space-time via the Higgs string, where that matter is oscillating in a circle, and that orbital path intersects the hologram at 2 places, sort of the 6 o'clock and the 12 o'clock position, we're going to see that the 4 electrons that Dirac needed to make his equation work are the entrance and exit points of the matter and energy that pass through the hologram at the bottom and the top of the orbital intersection with the holographic surface. And everything from the sign conventions and the orbit, where the positron, which is the negative electron, is actually going backwards in time, the electron's going forwards in time, we're going to absolutely see the sonic gravity theory of everything, the Rosetta Stone of the universe, models the charge, the time trajectory, the position, the direction, all of it. Dirac didn't know it, but his equation models the sonic gravity Rosetta Stone of the universe, and that too is a fact. And this next thing is just going to blow your mind. And if you're a physicist, when we get to the Dirac equation, it's absolutely going to blow your mind, and that is a fact. And we'll note how tension in the Higgs string, which is quantum gravity, pulls on the fabric of space-time. And I'm going to draw it, and you're going to see it right in front of your face, that Einstein's general relativity, which established that matter and energy bend the fabric of space-time, put a dent in the space-time, and it's that dent that causes other mass to sort of roll towards other massive objects because of gravity. And we'll see that when the Higgs string is tugging on the fabric of space-time, on the 2D holographic surface of the black hole, it's going to bend it, it's going to pull it, which is going to cause a dip. And so the sonic gravity theory of everything also exactly models general relativity, and that too is a fact. And then after that, I'm going to prove to you, according to the Velcro astronaut problem, it's the illustration I just made up, but it's going to prove to you that the assumption that the scientific community makes, that mass doesn't change with velocity, that mass is constant, they're wrong. I'm going to show you inconsistencies in Einstein's equations of motion that prove it can't be right, that prove that mass must reduce as a function of velocity. And that's going to give us the relationship between mass and velocity. Knowing that knowledge is what we need to realize, that when something accelerates, it transmutes part of its mass into a dark matter state to pay for that increase in velocity, to preserve conservation of mass energy within the surface of the hologram. So something goes faster, a little piece of its mass comes off the hologram. And when something moves at light speed, all of its mass comes off the hologram. And the reason that luminal speed limit exists is because at the speed of light, there's nothing on the holograms. There's nothing to accelerate, and so that's as fast as we can accelerate something from the hologram, and that is a fact. And when we realize that the Schrodinger equation, the Dirac equation, special relativity, and general relativity are all consistent with the sonic gravity theory of everything in the Rosetta Stone of the universe, we're going to realize that the elementary particles in the standard model are the particles that are going forward in time. And when they whip around, tethered by the Higgs string, and head backwards in time, they go through the hologram at the 6 o'clock position, they go forwards in time, they arc up, and they hit the 12 o'clock position, and then they're going back in time. That is what scientists think are antiparticles. Because under the right-hand rule, they're going the wrong way, with the wrong charge, backwards through time. But it's because we have this Cartesian model in our heads, we don't realize that there's a symmetry, that it's an orbiting particle, it's not a left and right particle, up and down particle. We're going to realize that the particles and antiparticles are the exact same particles. They're just going around in a circle, arcing out of and back into the hologram. And we realize that mass is a function of velocity. We're going to see that the tau, the muon, and the electron are all the same particle, just moving at different velocities. And as soon as we realize and accept that, it does violence to the standard model. It doesn't disturb anything that's measured or corroborated scientifically and experimentally under the standard model, but the interpretation of the energies and the failure to realize that as a muon creating a collision is just an electron whose light speed has been arrested by a sudden collision. So you have a big fat electron because it's got no velocity. Heavy particles produced in colliders don't decay, they just accelerate. Then it gets picked up by a positive ion and it starts to whip around it just like an electron orbits any other proton, and it achieves near luminal velocity as it rotates around that positive charged particle. And scientists think that this muon just decays and shoots out neutrinos. But neutrinos are just a marker for spacetime, and the neutrinos that scientists think they see are really just skid marks as that electron peels out. And the neutrino is really the mass action, called the Voorhees mass action, which is essentially the G's that carry away that mass of that electron as it accelerates, oscillating at near light speed. So when we see that, then it just executes, absolutely annihilates all the higher energy particles. We realize that the electron is the tau, the electron is the muon, just at different velocities. Near zero velocities immediately in the aftermath of collisions. And that's why muons decay slowly in the upper atmosphere near the poles, because there just aren't that many positive ions to pick them up. And they can even hit the ground before they get picked up by a positive ion. Anyway, yeah, it explains everything, and that too is a fact. Now I'm way behind, so I got a little bit carried away with this preview, so let me catch up on the drawing. So at the top, we're talking about Newtonian mechanics, a little classical mechanics. It's totally accepted. We all learned this in high school, probably, maybe, I'm pretty sure. So you got kinetic energy, it's the energy of motion. You got potential energy, that's the energy of height. And if you had a rock with mass on top of this cliff, at the initial time, when the rock is on top of the cliff, all of the energy in the system is described as potential energy. It's the mass times the acceleration due to gravity times the height. Now, if that rock falls off the cliff, as the rock falls, it's going to trade its potential energy for kinetic energy. And the formula for kinetic energy is 1/2 times the mass times the velocity squared. And at the end, at time 4 in that diagram, right before the rock hits the ground, all of its energy has been converted from potential energy to kinetic energy. That is a fact. It's essentially zero height, so there's zero potential energy, and it's all velocity. Now, the Lagrangian at any particular time is going to be the kinetic energy minus the potential energy. And in every instance in that time, and all times in between, from the beginning to the end, the kinetic energy plus the potential energy equals the total energy, and that is a fact. We call that the Hamiltonian. And all that means is that the energy doesn't get greater and it doesn't get less. The total energy, the Hamiltonian, is a fixed number, and it equals the kinetic energy plus the potential energy at every single time. It will always be equal. And you can see from time 1 to time 2 to time 3 to time 4, during that whole time, at the beginning it was all potential, and as it falls it trades it for kinetic, and at the bottom it's all kinetic, right before it hits the ground. And since all the energy is potential energy at time 1, and all the energy is kinetic energy at time 4, but the Hamiltonian means that at the beginning, at the end, and all times in between, the potential energy plus the kinetic energy equals the Hamiltonian, equals the total energy, and that never changes, and that is a fact. And so now we come to the Schrödinger equation, which is really the inception of quantum mechanics. And so before we get to quantum mechanics, what I want to do is I want to talk about the geometry of the Rosetta Stone of the universe. The sonic gravity Rosetta Stone says that all the matter and energy is oscillating around the surface of the hologram. We can only interact with matter and energy that's on the hologram. And so in this context, in this model, the kinetic energy, just like in Newtonian mechanics that we just talked about, isn't just velocity. It's actually the appearance of the mass in the hologram, right? The observable mass, that's actually part of the sort of active kinetic energy, because E equals mc squared. Mass is energy. And so that counts in the quantum Lagrangian. The mass that you can see counts as positive kinetic energy. And that is probably a fact. Maybe, probably, I'm pretty sure. That's the sonic gravity theory of everything anyway. But the potential energy isn't height like it is in Newtonian mechanics. The potential energy is the dark matter mass energy. But it's still just like Newtonian mechanics in the sense that the kinetic energy plus the potential energy equals the Hamiltonian, equals the total energy. So in this case, the energy on the hologram plus the energy off the hologram equals the total energy. And that is a fact. And so now you can see, right, the faster something starts moving inside the hologram, well, that means that some of the other kind of energy has to come off the hologram in order for the energy to stay the same. So if something moves faster, some energy has to come off the hologram for everything to still equal the Hamiltonian, for everything to stay the same. Because in the quantum Lagrangian, there's really only three kinds of energy. It's either mass on the hologram, it's momentum and velocity on the hologram, or it's dark matter. And if you increase the velocity, the only thing you can do is drop some mass, and drop some mass into the dark matter condensate, so to speak. I got that from Leonard Susskind, by the way. I was watching one of his lectures. I wish I could say I made it up, but it didn't. It was from Leonard Susskind. He was talking about the Higgs Field. Anyway, which is off the hologram. And anything that's off the hologram is going to be times that I. It's going to be an imaginary number, times the square root of -1. And that shows up in all the math. I don't think physicists really realize what that means, that it means off the hologram, but it does, and that is a fact. Just remember the energy on the hologram and the energy off the hologram has to equal the Hamiltonian, a fixed, constant number that represents the energy in the system. And don't get freaked out, it's really easy. It's I, which means imaginary, square root of -1, actually 0 plus the square root of -1, times the Planck constant, which is the smallest distance that we can measure anything, measure position and momentum, I should say, times the change in the energy in the wave equation, which is psi, the d psi over dt. That's just the change in the energy over time. And that equals the Hamiltonian of the wave equation. That equals the total energy in the wave equation. And that's really easy. And in Schrodinger's equation, when we realize that the Hamiltonian is actually a fixed number, it's not actually a function, and we replace the Hamiltonian of the wave equation with just a constant, because we know it's a constant, so call it h, and we integrate both sides with respect to psi, we get a real constant r plus I times psi. And that equals some constant h times the value of psi, which is the wave equation. Now don't let it confuse you. I messed up a little. I don't think 0 is a function. When I integrated with respect to psi and I brought up the new constant, I put psi times the constant r, and that's not right. It should just be a plain straight constant. But that makes sense because the energy on the hologram needs to be constant. Conservation mass energy, the Hamiltonian, all of our current Hamiltonian only concerns itself with the mass and energy on the hologram that we can interact with. And that's still constant, and so the matter and energy on the hologram is a constant r. It's not r psi, so sorry. But anyway, what that says is that the real component, which is all the energy on the hologram, plus the energy off the hologram, equals the Hamiltonian, equals some constant times the total energy in the wave equation. And that's a fact. So the math says that over that interval, the Planck constant, you can see in the diagram, the total energy is the energy on the hologram plus the energy off the hologram. It's completely consistent with Newtonian mechanics, and it's completely consistent with the sonic gravity theory of everything in the Rosetta Stone of the universe, and that too is a fact. So there you go. Newtonian mechanics and the Schrodinger equation, quantum mechanics, is consistent with the sonic gravity theory of everything in the Rosetta Stone of the universe. And that is a fact. Let me just demystify something real quick. You hear about quantum superposition of states. It's the probability that everything exists all the time at the same time, and Schrodinger's cat is alive and dead and all that kind of stuff. All that really means is, if you look at the energy off the hologram. If I tell you that the energy off the hologram is 6, you can't interact with it. There's too many degrees of freedom. You don't know what it is. Is it 6 plus 0? Is it 6 times 1? Is it 2 plus 2 plus 2? Or 5 plus 1? Or 12 times 1/2? Or 600 divided by 100? You just don't know. You can't tell. There's too many degrees of freedom about what that 6 off the hologram could mean. It's only when that 6 hits the hologram that you can make an observation. And so it's only when you make an observation and you go, oh, it's 3 plus 3. It's only when you make an observation that you understand the exact state of the energy and what that 6 is really kind of made of. And so it could be anything until you make that observation and check and see. That's all that means. It's not that tough. It really isn't. And that is a fact. But we can't stop there, because if the sonic gravity theory of of everything is actually the sonic gravity theory of everything, then it also has to be consistent with the Dirac equation. Paul Dirac was a French physicist, and he took the Schrodinger equation, and he took Einstein's equations of special relativity, and he made a baby with it. He called that baby the Dirac equation. Now, Einstein's equations for the energy of mass is E equals mc squared, and that's for mass at rest. But if mass has momentum, then its energy kind of goes into two dimensions. One is it's sort of a dimension of matter, which is E equals mc squared, and then there's momentum, which is mass times the velocity times the speed of light. And mass times velocity is momentum, and that equals p. And they don't just add together. It's not just this plus that. It's kind of like, it's what you call Euclidean, right? It's vector dimensions. And all that means is that the square of the energy equals the sum of the squares of the momentum energy and the matter energy at rest. And that is a fact. And so you can kind of think of it like a diagram, like the triangle, like a right triangle. So the momentum is like across the x-axis, and then the energy of mass is like the y-axis. And so it would just be like, if the momentum was 4 and the mass was 3, then the total energy of that mass at that momentum would be 5. And you'd get that, and the momentum was 4, the total energy would be 5, because it would be 3 squared plus 4 squared, which is 9 plus 16 equals 25. And so you take the square root of that, and the square root of 25 is 5. So the total energy would be 5. And that is a fact. And in the next one, we're going to get a little bit more into that, because we're going to look at velocity as a dimension too. And we're going to see that the reason that muons look like muons, which are actually just fat electrons, it's because if they have a dimension of velocity which is orbital around a proton, and a dimension of velocity which is linear in an accelerator, and they accelerate that electron attached to that proton to near the speed of light, then that means its rotational dimension around that proton has to pretty much go to 0, because linear dimension of velocity is almost c squared is the maximum velocity, and if you're almost at the speed of light, that means you're not rotating, and then all of a sudden, bang, when your linear momentum is zorched by a collision, then you have an electron that ain't rotating around anything, and it ain't going anywhere, so it's big and fat. And we're going to see that when something isn't moving, it must have more mass. And then it doesn't decay, it actually just accelerates as an ion picks it up and starts spinning it around at close to the speed of light. And so the muon decays into an electron. And they think it gives off antineutrinos, but it doesn't. Those neutrinos are just kind of the skid marks in space-time from the G's that are pulling some of that mass into a dark matter state as it accelerates in velocity. And the consensus in particle physics is that the muon just poops out lots of neutrinos and gets lighter. They call that decay, but it's not. It just loses mass as it accelerates, and that is a fact. Because let's be honest, man, if the muon is really an elementary particle, it can't be an elementary particle if it gets smaller, and that too is a fact. Or if it's made up by neutrinos. So there's kind of this fiction that, oh, well, you know, it's just a matter interaction. No, it's not. It's just that mass is a function of velocity. And that is probably a fact. Maybe, probably. I'm pretty sure. Anyway, we'll get there. I'll draw it out. You'll see. It's totally easy. But watch, in this episode, that is going to do violence to the standard model, and that too is a fact. So now we get to the Dirac equation. The Dirac equation is what happened when a brilliant French physicist, Paul Dirac, decided to take Einstein's equations for the energy of motion and the Schrodinger equation and make them have a baby. And don't get nervous. I know it looks like math salad when you look at it, but it's really, really easy when you think about it. And in order for it to be right, and for Newtonian mechanics to be right, and for the Schrodinger equation to be right, they're all talking about kind of the same thing. So that if all of those are right, they have to echo. They have to be mathematically modeling the same kind of thing. And so when you look at it, you just kind of at first glance, you have the equation is 2 times the Planck constant times gamma mu. And gamma is not just like a number. Gamma is a bunch of matrices, and mu is the number of the matrices. So there's actually 4 in Dirac's formulation, 4 number grids. And the reason was because he tried to make it work out, and he couldn't make it work out unless he used 4 electrons. And the reason he had to use 4 electrons is because he needed a value. He needed to match values. He needed to equate the energies that were entering the hologram on one side, then leaving the hologram on that side, then coming back around and entering the hologram from the back side and going out the front side of the hologram. So 4 electrons, because he needed 4 objects and their interaction directions to model that energy, just like the sonic gravity theory of everything. We're going to go through all that in just a second, and it's really simple. It's just not that tough when you look at the sonic gravity theory of everything and the Rosetta Stone of the universe. But just know that that's not really a number. It's like a set of matrices that just needs to get like multiplied through, which is just the jiggle factor in different directions, in different dimensions, so to speak. And you take the derivative of that, all those changes with respect to the wave equation. So it's really just how does the wave equation change in all those directions? And then it's minus the mass times the speed of light times pitchfork. Which, it looks like a pitchfork, doesn't it? Well, it's psi, which is the value of the wave equation at that particular moment. And it equals 0. Do you see a similarity there? Yeah, the first term is really a kinetic term that talks about motion, which is really just a change in the direction and distance of the jiggle. And the second term looks a lot like the potential energy that we saw in Newtonian mechanics when the rock was on top of the cliff. And back then, that potential energy term was just the mass times the height times the acceleration due to gravity, and that is a fact. And remember in Newtonian mechanics when we said that at the first time, all of the energy was potential energy, mass times the biggest height times the acceleration due to gravity. But then at the end, at the bottom, the time 4, where it like fell off the cliff and it was going as fast as possible right before it hit, it was all kinetic energy, 1/2 mv squared. And 1/2 times 4 is 2, which is in front of that first kinetic term in the Dirac equation, just saying. All of the energy was kinetic and the potential energy was 0. And the Hamiltonian said that at the very end, all of the kinetic energy, where it was all kinetic, had to equal back before when all the energy was potential. And so you have an equation that looks a lot like the kinetic energy at the end has to equal the potential energy at the beginning. So the kinetic energy at the end minus the potential energy at the beginning equals 0 because they have to be equal because the Hamiltonian. Remember the Dirac equation, it ended with the Hamiltonian of pitchfork. And in the Dirac equation, we're assuming teeny weeny distances. And so what that looks like is that the kinetic energy, a teeny weeny change in the kinetic energy has to result in equal a teeny weeny change in this mass potential. Mass times the speed of light times psi. I like to call it pitchfork. And I think the scientific consensus for the most part is that that value in that last term, psi, is what changes. Like m is constant, c is constant, and what's going to change is the psi. But here's the thing. I don't think it's just the psi that changes. The sonic gravity theory of everything, just like we said before, there's only like 3 kinds of energy in the whole system. There's the dark matter energy, which is the energy of mass off the hologram. And then there's kinetic energy on the hologram. And then there's the mc squared on the hologram. And we already said that in order for energy on the hologram to stay the same, if something speeds up, the mass part has to reduce too, because the energy on the hologram can't change. So you have energy of mass and you have energy of momentum. And if momentum increases, in order to keep the energy all the same on the face of the hologram, the mass has to decrease. We're going to talk more about that later. But essentially, I think what the Dirac equation is saying, at least in the sonic gravity theory of everything context, is on the surface of that hologram, you got a jiggle. And you know what? If that jiggle goes up, the second term, some mass has to come off so that it equals, so the change equals 0. And so just at a very high level, consistent with Newtonian mechanics, consistent with the Schrodinger equation, the Dirac equation is saying exactly what the sonic gravity theory of everything requires it to model. And that is on the surface of the hologram, if momentum increases, mass must decrease to keep the energy the same on the hologram. And that is a fact. Probably, maybe, I'm pretty sure. But it doesn't stop there. That's pretty persuasive to me. But this next part, when we break down these jiggle matrices, this is going to freak you out. That is a fact. And I'm not kidding. When we start to unpack these matrices, these jiggle factors, you'll know for sure, and that is a fact. And that looks kind of scary at first, but it's really not. Because think of those number grids as like jiggle factors. And when you jiggle one and move one, it's going to actually kind of shake the other ones. And so when you put an input in there, it puts out a bunch of little factors in this grid. And that tells you how it jiggles everything else. And Paul Dirac wanted to model electrons that move in an electromagnetic field. And the things that you need to model, the inputs that you need to model when you do that, is the direction of a particle, the charge of the particle, a time component, which is actually modeled as positive or negative lowercase italicized I, which is crazy because on the left or right side of the holographic surface of the universe, peeled off the quantum donut and hung like a sheet, to the left of that sheet is negative I, and to the right of that sheet is positive I, because that's off the hologram. That's time in the future and past. So when I saw that and I really looked at it, that's when I started freaking out, because when Paul Dirac had a baby, he was actually having a baby with the sonic gravity theory of everything. And that is a fact. And then the last piece is the force that acts on the particle in the direction, charge, and time direction of that component. It all goes by what we call the right-hand rule. Now, mind you, this is going to look like it was totally done in the context of the sonic gravity theory of everything and the Rosetta Stone of the universe, but it absolutely wasn't. I don't know how Paul Dirac figured out his matrices without the sonic gravity theory of everything, that our universe exists in a black hole and that time can be modeled like a movie reel, where the 2D holographic surface of the black hole captures the state of the energy at every point in time in the universe. And we can peel the two-dimensional holographic surface away from the black hole and hang it like a sheet. And if we do that for every instance of time from the beginning of the universe to the end of the universe and stack them like we're chopping the frames out of the movie reel from the very beginning of time to the end of time, then the distance across the slices of cheese, across the thicknesses of the frames, becomes time-like. And so then take one of those instances of time, the state of the energy in the universe at any one particular point in time, and look down the thickness of it. That's what the Dirac equation is modeling. All the matter and energy in the universe is orbiting in a circle, leashed to that instance of time by the Higgs field. And all that matter and energy is swinging around in a counterclockwise circle tethered to the surface of space-time, to the face of the hologram, to the surface of the black hole by the Higgs string. And imagine it swinging around in a counterclockwise direction. And the matter and energy in that orbit is going to intersect the hologram at 6 o'clock position and the 12 o'clock position. So the first electron that Dirac modeled was at the 6 o'clock position on the left, and we're going to call that A. Then if you follow around through the hologram to the other side, so it's at the 6 o'clock position, leaving the hologram into the future, that's B. And then it swings back up around, and it's heading back into the hologram at the 12 o'clock position from the future into the hologram, that's C, and exiting the hologram into the past is the D electron. And look at how Dirac writes his matrices. The first column is A, the second is B, the third is C, and the fourth is D. And each of those matrices is going to be talking about a different quality. And each one of those electrons has a little bit different quality in one of the other attributes, whether it's direction, spin, the charge, or the electromagnetic force. They're all a little bit different. But if you track and you look at the diagram that corresponds to the right matrix, that corresponds to the right electron, the Dirac matrices reflect the sign convention of the electrons as positioned in the sonic gravity theory of everything, the Rosetta Stone of the universe. And that is a fact. And just like Newtonian mechanics, just like the Schrodinger equation, it's all about balance. The energy that goes from A to B has to equal the energy that pops out at C and goes from C to D. And that has to equal the energy that goes from D to A, and so on. Rinse and repeat. That is the Hamiltonian. It's the same in classical mechanics. It's the same in Newtonian mechanics. It's the same in the Schrodinger equation. It's the same in Einstein's equations for the energy of motion, and it's the same in the Dirac equation. And it's the same in the Rosetta Stone of the universe and the sonic gravity theory of everything. And that is a fact. And so as you can see, I'm filling in these Dirac matrices. The first column's the A electron, the second column's the B, the third is the C, and the fourth is the D. And I'm just kind of going around to each electron. And as I fill in the matrix, I'm writing in whatever quality I read off of the chart into the matrix. Except for the fact that, and I know it looks like when I do that, I'm just reading it right out of the chart, but I'm not. I mean, that's actually, in every textbook, that is the configuration of the Dirac matrices. And that last matrices is electromagnetic force, and you get that with the right-hand rule. And so you can see, like, I'm pointing my index finger. For any electron, I'm pointing my index finger in the direction of travel, and I point my middle finger in the direction of the charge. And then your thumb is the direction of the force. And so you just pick a sign convention, like the force is coming at you and that's positive, or it's going into the page and that's negative. That's how you get that one. And what that means is the sonic gravity theory of everything and the Rosetta Stone of the universe is perfectly and completely mathematically described by the Dirac equation. And that too is a fact. And guess what? Did you see it? Did I sneak it past you? Did you see it? Yeah. You want to know what antimatter is? Antimatter is the reverse trip back through the hologram from C to D. So antimatter is actually matter. The only reason it looks like antimatter is because our sort of primitive Cartesian positive negative XY sign conventions don't recognize the symmetries that arise from living on the 2D holographic surface of a black hole. Yes, antimatter is not a different kind of particle. It's just our particle, our matter, on the backswing through the hologram. And so matter and antimatter annihilation, it's not just when an antimatter particle zipping through the atmosphere hits a regular particle. The only time matter-antimatter annihilation happens is when matter achieves absolute rest. Because it's only when the 6 o'clock and the 12 o'clock position for the same matter make contact. And that's only going to happen in a Big Bang for reasons that we've already talked about, when a collapsing star rips out of space and time, or in a particle collider where the collision leaves some matter at absolute rest, where it has zero velocity. Because when it has zero velocity and there's nothing off the hologram, it's like infinite gravity in that one little spot. There's nothing oscillating around the hologram. It'll just all collapse. Probably crushes down past the Planck level. And then you get matter-antimatter annihilation. Probably, maybe, I'm pretty sure. But yeah, and so when you realize that there's actually no different special antiparticle. And first I'm going to show you how general relativity is predicted by the sonic gravity theory of everything. The tension in the Higgs string bends space-time. The tether on the surface of the black hole, when it pulls, it's going to make a dip. It's going to deflect the space-time. But when you get to special relativity, and if you're not already convinced, when you realize that mass is a function of velocity, do you see it? Do you see what's going to happen to the standard model? Yeah, bigly. All right, so in this illustration at this point, what I've recapped is how the sonic gravity theory of everything, the Rosetta Stone of the universe, is not inconsistent with classical Newtonian mechanics or quantum mechanics described by the Schrödinger equation and the Dirac equation. In this illustration, I'm trying to demonstrate, in the movie reel, in the instances of time on the surface of the black hole, the first slice of cheese, the first frame, is without mass. So there's a vacuum expectation value for the Higgs field, and the scientific consensus on the expectation value of the Higgs field is 246 gigaelectron volts in the vacuum. The sonic gravity theory of everything, for reasons that we'll get into in a different episode or tutorial. The sonic gravity theory of everything proposes that the vacuum field value expectation is actually negative 246 gigaelectron volts, because the sonic gravity theory of everything proposes that the Higgs field is the gravity field, and gravity is negative energy density, so the Higgs field vacuum energy density must be negative, and that is probably a fact. Maybe, probably. I'm pretty sure. It is in the sonic gravity theory of everything. And so you can see, since gravity is tension in the Higgs string, and the Higgs string tethers all the matter and energy in the universe to the surface, the 2D holographic surface of our black hole, you can see in the second frame, see the little movie reel there, and then there's one frame that's a vacuum, and then the next frame over is one where there's mass in it. And you can see the mass is oscillating in a circle, tethered to the surface of the black hole by the Higgs string, where gravity is tension in the Higgs string that is leashing all the matter and energy there to our surface of the black hole, to our instance of Planck time. And that tension in the Higgs string, that pull, the leash that's leashing the matter and energy to the surface of our black hole, as that thing is oscillating around, it's actually pulling, it's deflecting the space-time. And it's that deflection, it's that dip, that general relativity that Einstein said was gravity. And he's right, it is. And you can see how the sonic gravity theory of everything respects general relativity, because sonic gravity theory of everything proposes that gravity is tension in the Higgs string, and the Higgs string is what's leashing all the matter and energy to our instance of Planck time, to the 2D holographic surface of our black hole, which is a quantum donut. And it's that leash, it's that tension in the Higgs string that deflects space-time. You can see as it pulls on space-time, it deflects it. And general relativity says that that deflection is gravity. So the sonic gravity theory of everything is consistent with general relativity, and that is a fact. And so now we come to special relativity. And in examining special relativity and the sonic gravity theory of everything's compatibility and actually completion of the equations of special relativity and the energy of mass and momentum, we said before that the energy of mass, E equals mc squared, was E equals mc squared. In the God equation tutorial, we talked about how the actual energy of mass, including the dark matter, is 4 pi divided by the g factor of the electron times the observable mass times the speed of light squared. But for now, let's just keep it in terms of Einstein's special relativity equation, where E squared equals mc squared squared plus the momentum times the speed of light squared. And we know this is incomplete. We know this is wrong, because if we take E squared equals mc squared plus pc squared, and if we substitute the speed of light for the velocity, then we get e squared equals mc squared squared plus mc squared squared. Then when we take the square root of that, we get e equals the square root of 2 times mc squared. And we know e can never equals the square root of 2 times mc squared because we know e equals mc squared. And it can't be both. And it doesn't work at the speed of light, and it doesn't work at 0.999 the speed of light. It just doesn't work. There's something missing, and that is a fact. And so like we've said before, the sonic gravity theory of everything's principle that resolves the issue, that unites the Lagrangian and the Hamiltonian, that completes Einstein's equation, is consistent with Newtonian mechanics, the Schrodinger equation, the Dirac equation, and is just kind of intuitively obvious. Explains everything from the G factor of the Einstein to Haas effect, general relativity and special relativity, particle collisions, an elementary particle, finger quotes, decay, end finger quotes, is that mass varies inversely with the velocity. When velocity goes down, mass goes up. When velocity is 0, mass is theoretically true mass with all the energy on the hologram. When velocity is the speed of light, the mass on the hologram is 0. The energy is still there. Still has gravity, but it's off the hologram. It can't interact with it. Maybe, probably. I'm pretty sure. And nothing on the hologram can ever accelerate anything past the luminal speed limit because as velocity approaches light speed, mass approaches 0, and when you hit light speed, there's no mass on the hologram, so there's nothing to apply force to accelerate. And that is probably a fact. Maybe. Probably. I'm pretty sure. Buckle up, this is where we unify the Lagrangian and the Hamiltonian. Complete Einstein's equations for the energy of motion. And because there's no antiparticles, because it's the same particles circling back through the other side of the hologram, and because elementary particle mass varies with velocity, radically simplify the standard model for particle physics. And the reason that some of our matter is dark matter right now is because in our current inertial frame of reference, we're spinning around the axis of the Earth is revolving around the Sun is spinning in an arm of the Milky Way galaxy, like on a pinwheel. The Milky Way galaxy is hurtling towards Andromeda. So the only thing that's really safe to say is that the Earth is in a non-zero inertial reference frame. And what that's like is like when you spit on the sidewalk, you're not going anywhere, but when you're inside your car and you spit, it looks the same. And so the reason that the equation for the energy of mass isn't actually E equals mc squared is because we're not on the sidewalk spitting. We're actually kind of in a car spitting. And mass, energy on the hologram varies with velocity, and we use dark matter in the geometry of the Rosetta Stone of the universe in a previous tutorial in my first one to derive the God equation. And we figured out that in our frame of reference, when our consciousness makes observations and takes measurements, the limitations of our consciousness and our ability to interact with mass and energy means we have to factor the energy and the mass that we measure if we want to get the true energy of mass. And we derived that. We called that the God equation, which is actually just the Einstein-Voorhees energy of mass equation, which is the same as E equals mc squared, except for it accounts for all of the dark matter off the hologram. And that equation is E equals 4 pi divided by the G factor times the observable mass times the speed of light squared. And the simplest, most natural equation that I could think of to model a relationship between velocity and mass is the cosine function. Because cosine of 0 is 1, and cosine pi over 2 radians is 0. What that means is that when velocity is 0, the factor is 1, which is the identity of the true mass. 1 times the true mass. And I set up the cosine function, so at the speed of light, the cosine function will multiply the true mass by 0 and make it 0. Make the observable mass 0. So the sonic gravity theory of everything's equation for observable mass is the true mass times cosine pi v squared divided by 2c squared. That's the equation that gives you that, and that is a fact. And so if you graph that with the mass on the hologram on the y-axis and velocity along the x-axis, you see a cosine wave, and where velocity equals c, the mass is 0, and faster than c, the mass is negative, which means the mass is going back in time, which is exactly consistent with the sonic gravity theory of everything black hole genesis that we talked about in a previous video. And it's the same thing Einstein said, so you know it's right. Maybe, probably, I'm pretty sure. That's the sonic gravity theory of everything, anyway. That is a fact. And it also explains how in collisions, which is the only way that these colliders ever get to see muons and tau particles and strange quarks and top quarks, is they have to smash these particles, which essentially takes them from the speed of light to zero in an instant. And all of a sudden, these big, fat, heavy particles pop into existence. And we think the particles that were this big were always there, but we just released them when they crashed. And then they just decay. They just get smaller for some reason. That's not what happens. They just get picked back up into the environment, start oscillating, and they oscillate at close to the speed of light, so that's why they shrink. That's why they lose observable mass, is because they speed up. Not linearly, they speed up by oscillating, by getting picked up by something and spinning around really fast. Because that's still a velocity, and that is a fact. Now, for the last 40 minutes, we've been talking about the sonic gravity theory of everything, how it's consistent with Newtonian mechanics, quantum mechanics, it's internally consistent with general and special relativity, and we learned that antiparticles are just the same particles we have, but just backswinging through the other side of the hologram as it orbits the holographic surface of the black hole, and we just showed that mass is a function of velocity. Now watch what that does to the standard model. Yep, say goodbye to all the antiparticles that are just regular particles swinging back through the hologram in the opposite direction. Say goodbye to the 3 generations of matter, because it's the same matter going a little slower. And we'll see shortly that the Higgs is actually responsible for bending space-time, which is gravity, but mass is determined by the action of the Z boson, but that's a function of the geometry of space-time. And this is when I realized, actually when I was doing this diagram, and I figured out that the thickness of the hologram isn't actually one Planck length. Can't be one Planck length. It's actually a Planck constant, I'm pretty sure. And I figured that out from the Dirac equation. And if you look at the derivation of the Schrodinger equation way back when we took the integral of the Planck constant to simplify the equation, and when you look at the Dirac equation, the space-time integral is 2 times the Planck constant, which might reflect 2 passes through the thickness of the hologram. And then if we say, and this, what I'm about to say, this comes from a lecture I saw, a free Stanford lecture I saw on YouTube by Leonard Susskind, who said that mass is actually a function of the amount of interaction that energy has with the Z boson. And the sonic gravity theory of everything would add on to what Leonard Susskind said, is that mass is a function of the amount of interaction the Z boson has with energy oscillating around the surface of the hologram, based on the amount of contact it has with the hologram, which makes perfect sense, because as the Higgs bends space-time, if it's elastic, the more it bends it, the more it thins out. The thinner space-time gets, the less interaction it will have with the Z boson that I believe carries energy through the hologram. And so the more space-time is deflected by quantum gravity, the less interaction it has with the Z boson that exists in the hologram, in the thickness of the hologram. And I'm going to talk about neutrinos as the fabric of space-time in just a second, but I need to cover the quark really quick, because the quark was a little bit gnarly, and it took me a minute to sort of figure it out, because the up quark is 2.2 mega electron volts. The down quark is 4.7 mega electron volts. And the charge of the up quark is 2/3, which is kind of weird, right? You wouldn't think that. It's strange. How could you get 2/3 charge? And the charge of the down quark, and it's heavier, is negative 1/3. Well, all physicists know that there's 3 quarks inside a proton. So when we put 3 spheres next to each other, it can only ever be in a triangle, right? And if we reflect on the Dirac equation's derivation of the Dirac matrices, and we apply that and stick that triangle on top of the charge matrix, we can see we're going to have 2 quarks. And if we assume a net positive charge sort of on those quarks, we're going to have 1 quark probably stuck to the bottom where the negative electron is, right? Because they're going to attract. And then we'd have 2 quarks in the upper section of the charge diagram, but they would be repelling, right? And the only way to get the furthest distance from that positron up there, which is a positive charge, and the positive 2 quarks that are there, is to kind of have 2 kind of spaced out equidistant. And look, the masses are different too. The mass of the down quark, which is in the bottom, in the negative charge side, which is why it's negative 1/3, is going to be moving a lot less than the 2 up quarks that are probably not just rotating, but spinning laterally. And so they're spinning laterally. That's sort of a different dimension of velocity that the down quark, finger quotes, doesn't have. So that's why the up quark has 1/3 charge and is half the observable mass of the down quark, which has a minus 1/3 charge. Because in the Dirac matrix, if you're in the bottom, you have a negative charge. If you're in the top, you have a positive charge. So everything makes sense. There's no way I couldn't make this up. And the only way that the sonic gravity theory of everything can account for this, the fact that all the matter and energy in the universe is oscillating, leashed to the surface of space-time, which is the 2D holographic surface of the black hole. That's the only way you get here. And no matter what you throw at the sonic gravity Rosetta Stone of the universe, everything is explained. It's unbelievable. It's unbelievable to me. We nailed it. We have the theory of everything. And that is probably a fact. Maybe, probably, I'm pretty sure. So the mass would get lighter. So everything makes perfect sense. It's all internally consistent. And then you think, well, what comprises? What's the Higgs actually bending? What is the substance of the hologram? And I think that might be what the neutrino is. The neutrino might be the grid paper that is the surface, that marks the surface in time of the hologram. And they say that billions and billions of neutrinos pass through us all the time. And that's why I think that it's possible that the fabric of space might be the neutrino. And we're sitting on the hologram, and then my mind just exploded, and it felt like my brain was racing through space, and I achieved illumination when I remembered this.
Except, the thing is, even if I believed you, right, where you're from, what I've done, which I don't, by the way, you're still talking about beaming aboard the Enterprise while she's travelling faster than light without a proper receiving pad. The notion of transwarp beaming is like trying to hit a bullet with a smaller bullet whilst wearing a blindfold, riding a horse. What's that?
Your equation for achieving transwarp beaming.
He's out of it. Imagine that. It never occurred to me to think of space as the thing that was moving.
Because the sonic gravity theory of everything holds that space-time blows out of black holes. And if time is passing through us, there's no reason to think that space isn't passing through us too, because it's not time, it's space-time. Which actually accounts for universal expansion, cosmic strings, high neutrino density squirting out from within the donut hole of the black hole universe. Black holes are all quantum donuts, just saying. And it explains why black holes become pulsars, because there's a bunch of space blowing out of the donut, all bunching up in the middle, inward into the hole from all directions at each other, and so it has to squirt out the top and bottom really fast, just saying. And so everything fits, all the puzzle pieces fit. And if billions and billions of neutrinos are passing through us all the time, then it's hard to argue that the neutrinos aren't space-time, and space-time isn't passing through the 2D holographic surface of the black hole, which is a quantum donut containing our universe. And that is probably a fact. Maybe, probably, I'm pretty sure. It's definitely the sonic gravity theory of everything, and that is a fact. And we actually haven't even scratched the surface of the things that the sonic gravity theory of everything predicts. But let me blow your mind really quick. If space-time is actually blowing through the 2D holographic surface of the black hole, which is a quantum donut, and space-time blowing through the hologram is changing the hologram, which is what we notice as the passage of time. And if space-time needs energy to change the hologram, and our consciousness also uses the same energy to run our brain, the energy for those synapses, for those neurons to fire, has to come from somewhere. And if the energy on the surface of the black hole is constant and fixed, and we have no reason to think it isn't from the law of conservation of mass energy, then our neurons might compete for the same energy that space-time uses to change the hologram. And if we compare the neuron density of the hummingbird, which is 650 million neurons per gram, and the human, which is 53 million neurons per gram, it's possible that the consciousness of the hummingbird deprives space-time of much more energy it needs to change the hologram than the human brain does. If the hummingbird's consciousness is sucking way more energy off the surface of the black hole than the human brain's neuron density is, that might account for hummingbird celerity. The consciousness of the hummingbird and its high neuron density might be slowing the flow of its time, which means it doesn't move lightning fast because it has fast muscles. It moves lightning fast because it has slow time. And that is probably a fact. Maybe, probably, I'm pretty sure. And if our active consciousness is actually constipating the flow of time, causing a time jam, the psychic pressure on our consciousness under the arrow of time might be what makes us tired. And that could be a fact. Maybe, probably, I'm pretty sure. And maybe that's why the muscles that our consciousness controls get tired. But our heart, it could beat for 70 years solid, never stop. Well, until you die anyway. And the bumblebee that beats its wings 600 times a second with a neuron density of over 1 trillion neurons per gram. Well, the sonic gravity theory of everything seems to be the least silly explanation for the unexplainable. And that is a fact. And you know it really is a theory of everything. You know it's the theory of everything. When it starts predicting solutions that match verifiable reality, and those solutions are solutions to questions we didn't even know we weren't asking. And that is a fact. So the Rosetta Stone of the universe, the sonic gravity Rosetta Stone of the universe, predicts and explains things things all around us that we haven't even thought of as mysteries yet. And that too is a fact. And I know we're running long, so we're going to hurry up and finish. And when we write Einstein's equations of motions, you're going to see that we actually, at the quantum level, we're actually going to unite the Lagrangian and the Hamiltonian in a single equation. Maybe, probably, I'm pretty sure. You be the judge. But if we do, and in just a second, when you see it, you'll know it. And when science goes, yeah, that's legit, we're going to call it the Voorheesian. That too is a fact. And so I talked a little bit before about how Einstein's equations for the energy of motion were incomplete. And my initial notion of that came when I just looked at the equation E squared equals mc squared plus pc squared, where p equals mass times velocity. Because at the speed of light, E squared, when you plug everything in, then E becomes square root of 2 mc squared. And E should be mc squared. And it couldn't be right. So I didn't think that Einstein's equations for the energy of mass and momentum, I didn't think they could be right. And I'm pretty sure he knew they weren't right either. But the scientific community is under the misimpression that mass approaches infinity at the speed of light instead of 0. And the reason they're confusing that is because there is a luminal speed limit, but it's not because everything gets super duper massive as it approaches the speed of light. It's because its mass goes to 0, and at the speed of light, its mass is 0, and you can't accelerate it past that. And that's the same, and that works out in the math the exact same way that the free energy electron does in Feynman path integrals. And every physicist knows that for most of the orbit, when the electron is off the hologram, the math says the electron's mass goes to infinity. And everybody knows that doesn't happen, and so they cheat. And they just say, well, we know our mass says it goes to infinity, but we don't care. We're just going to substitute in what we know the mass is. And that is a fact. So it's just another example of when things go off the hologram, our current mathematical models just flip out and don't know what to do. It's not because they're like not smart or don't know what they're doing or anything like that. They absolutely know what they're doing. They're brilliant physicists. Trouble is that the mathematical models that they use in the paradigms weren't derived with the symmetries that are embedded in the sonic gravity Rosetta Stone of the universe. And that is a fact. So I couldn't really use the whole equals the square root of 2 times mc squared at the speed of light to illustrate the shortcomings of Einstein's equations for the energy of mass and momentum, because the first line of defense for any consensus physicist would be, oh, well, that's because mass goes to infinity. And so talking about conditions at the speed of light wouldn't be fruitful. So I had to come up with an illustration that was lower energy, but just as persuasive. And so I thought up the Velcro astronaut problem. And so we know from the sonic gravity Rosetta Stone of the universe that the 2D holographic surface of the donut, the black hole that is our universe, you can peel the surface of that black hole off at any instance in time, and whatever's on the hologram is the complete state of existence of the universe in that instance of time. And you can hang that 2D holographic surface like a sheet, and that's like a frame in a movie. And if you want, you could take the entire reel, every state of the energies in the universe from the very beginning of time to the end of time would be encoded as frames in that reel of movie film. And you could chop all those frames out and stack them from the beginning of time to the end of time. And the energy, the mass and energy leashed to the surface of all of those frames has to be equal from the beginning of time to the end of time. And that is a fact. And so now what I want you to do is somewhere in the beginning, I want you to imagine 2 spheres, 2 bubbles. And those are what we call closed systems. No energy comes in or out of them bubbles. And in that frame itself is a closed system too. No energy goes in or out of that frame. It all has to stay the same. And inside those bubbles, I want you to think of 2 astronauts that are kind of squatting down. They're back to back, each inside their bubbles. And they're in these Velcro suits. And the inside of the bubble, except for where their feet are, is all Velcro too. Except it's the opposite side of the Velcro, so like it'll stick to them. So in one earlier frame, their bubbles are right next to each other. They're squatting down, facing opposite ways. And then somewhere in the middle, they both jump at the same time. Their bubbles are still together, but they're flying through the middle of the bubble until they both hit the opposite side of the bubble and they stick. The Velcro sticks them. Now the momentum that they created when they jumped transfers to the total mass of them plus the bubble when they impact the far side of their bubble. And so then the bubbles start moving apart. They have to because of conservation of momentum. And so then at some time in the future, after they've jumped, after they've stuck, and after the bubbles start moving away from each other, it's a closed system. So the energy all has to be the same. The energy energy in the first frame when they're still, and the energy in the last frame when both the bubbles are moving. And no matter what the Velcro astronauts did inside the bubble, doesn't matter because the bubbles themselves are closed systems. So whatever happened inside the bubble, all of the energy of the bubble and inside the bubble is the same as it was before too. And now there's a big problem, because if Einstein's equations of motion are correct, then in the first frame, the energy has to be E equals mc squared. But in the frame of the future, when the same bubbles, the same mass, they're still both in the frame, but now there's no denying that the bubbles are now moving too. And what that means is, in the first frame, the only energy is E equals mc squared. And in the second frame, the energy is E equals mc squared plus the energy of momentum that has to account for the movement of the bubbles, which is non-zero now. And the total energy in the first frame, where the bubbles aren't moving, has to equal the total energy in that last frame, where the same bubbles are there, but now they're moving. And everything that's in that equation, and that's the one that's E squared equals mc squared squared plus pc squared, has to be equal to mc squared in the first frame. And it is. It has to be because of conservation mass energy. But the only terms that can be variables in those equations between the first frame, where E squared equals mc squared squared, and the future one, where E squared equals mc squared squared plus the quantity pc squared, there are only two quantities in that equation that can possibly be variable. C is a constant that never changes because of the invariance of the speed of light, and E is a constant that never changes because of the law of conservation of mass energy. There's only velocity, which we know is increasing, and the only term that's left in the equation is mass. And the mass is what changes, and that is a fact. The mass changes because it must. The observable mass must drop to make room for the increase in the energy of momentum in order to observe the law of conservation of mass energy, and that must be a fact. It's the only way. So the sonic gravity theory of everything has to complete Einstein's equations. It has to connect a mechanism that allows velocity to reduce mass. It's not reducing the total mass. Some of that mass is just transmuting into a dark matter state, and the observable mass is what's dropping. The observable mass on the hologram is what drops a little bit. And it's the acceleration, it's the increase in the velocity, it's the G's you feel. That's the feeling you get when some observable mass comes off the hologram and enters a dark matter state. And so what we need to add to Einstein's equations of motion is a term that accounts for the dark matter. And the funny thing is when we make that term, the dark matter mass term, and if we think of that as mass potential, the same way we do in Newtonian mechanics, remember where the Lagrangian equals the kinetic energy minus the potential energy. So we know from the Lagrangian that we have to subtract the potential energy, which is the dark matter mass energy. So now we don't really have mc squared anymore. We have m observable c squared times pc, and the second term, pc, which is mass times velocity, we have observable mass times velocity. And those two terms, the energy and the mass on the hologram, that's what we're going to consider kinetic energy in this context. And for the Lagrangian, then we know we minus the potential energy. And the potential energy is the dark matter mass. There's like E equals mc squared for the dark matter mass. But we can just call it dark matter mass, or MD. And now we have a really interesting extra equation that comes out of that, and that is the true mass equals the observable mass plus the dark matter mass. So the complete Einstein-Voorhees equation for the energy of mass and momentum is the God equation squared, 4 pi divided by the G factor times the observable mass times the speed of light squared, which is the total E squared, equals observable mass times c squared, plus the observable mass times the velocity times c, all that squared, minus md, which is the dark matter mass, times c squared. We have to multiply it by our little lowercase italicized I because it's off the hologram, then all that squared. And the beautiful thing is that at the speed of light, the observable mass drops to 0, and the first two kinetic terms drop out. So then all we have is minus the dark matter mass times the speed of light squared, and that is squared. But when you square I, you get -1. And so at the speed of light, E equals -mc squared times -1. E equals mc squared, and that is a fact. And by characterizing the observable mass and energy on the hologram as kinetic energy in the context of the Lagrangian, and subtracting the potential mass energy, which is the dark matter mass, defines consciousness and explains its role in limiting our ability to perceive the universe with our observations and measurement, that equals the total energy, and that is a fact. So the sonic gravity theory of everything and the sonic gravity Rosetta Stone of the universe unites classical mechanics, quantum mechanics, including the Schrödinger equation and the Dirac equation, explains the increase in mass and the mass decay in experiments and particle collisions, gives us the theory for quantum gravity, validates the principle of the holographic universe, models general relativity, embodies general relativity and special relativity, and in doing so unifies the Lagrangian and the Hamiltonian, simplifies the standard model, derived the God equation, accounts for universal expansion, and that is a fact. But the sonic gravity theory of everything doesn't end there. This is just the beginning. You see the black hole M87, the quantum donut? It's a ring. It's a ring that ripped out of space and time when the collapsing star and the law of conservation of angular momentum forced the core at some radius to spin faster than the speed of light. It ripped out of time and left a quantum donut. And inside, a new universe big banged. And you see those ridges that ring the M87 quantum donut? You see those rings around the ring of M87? All those ridges? Those ridges are rings too. Black holes within the black hole universe of M87. And that is probably a fact. Maybe, probably. I'm pretty sure. And if our consciousness is in fact energy running over the 2D holographic surface of the black hole that is our universe, then that means when we die, our energy leaves the surface of the black hole as Hawking radiation, carrying with us the information that we've recorded in our memories and DNA, because we are the universe's mechanism for the law of conservation of quantum information, where our consciousness enables us to make observations, and our intelligence enables us to assimilate and connect our observations, and where emotion enables us to deeply etch that information into our memories. Because everyone knows that you can forget information almost immediately, but you will remember how something made you feel for years, maybe even your entire life, and that is a fact. And when we die, our energy and information, which cannot be destroyed under the law of conservation of mass energy and the law of conservation of quantum information. So yes, our souls are immortal, and that is a fact. And when we die, we leave the surface of the black hole, perhaps in fractal ascension to our parent black hole, the black hole that contains our universe. And if we hit the surface of that hologram and manifest inside that universe, the same way we've manifested in this universe, that could be reincarnation. Or if we ascend to the primordial black hole, to the first black hole, we might find ourselves, our consciousness might find itself manifesting in what we could only call heaven. And that too is a fact. So this isn't the end, it's just the beginning. In the same way, time travel, UFO flight, zero-point energy propulsion, immortality, anti-gravity, it's all here in the sonic gravity theory of everything. And when you orbit in sonic gravity and see the universe through the eyes of a madman, you'll stare into madness and madness will stare back into you. And you'll know for certain. And the next time you stare at a picture of M87 and see a quantum donut and the rings around that quantum donut as the black holes within M87, and you will know that I am inside your mind too. That too is a fact.